Welcome to Pact Publishing's screencast series on mastering PrimeFaces. My name is Josh Juneau, and I'll be your presenter for this course. This series focuses on the PrimeFaces framework, assuming that you have an understanding of what the PrimeFaces framework has to offer. For those of you who have used PrimeFaces before, this series will help you extend your knowledge, and I'll be showing you some advanced usage of PrimeFaces components, Ajax functionality, client-side validation, and more. Throughout the series, we'll be looking a lot at the PrimeFaces website, as it plays an important role in the developer's understanding of the components, since it contains the PrimeFaces showcase, documentation, and much more. We'll be using NetBeans IDE in this video, although you could use any Java IDE that has support for Java Server Faces framework. We'll be developing a Java EE web application throughout this video series, and it will be an application for an auto sales organization named Prime Auto Sales. To get started, let's create a Java EE7 web-based application within NetBeans IDE and name it accordingly. First, open the NetBeans IDE and click on New Project and choose the Maven category. Then, select the Web Application Project. Click Next and name the project accordingly, Prime Auto Sales. Choose a project location, then type a version. I'm assuming you have previously configured your NetBeans IDE with a local Glassfish development server. If not, then please do so before proceeding. This can be easily accomplished by opening the Services tab, right-clicking on Servers node, then choosing Add Server. In this case, we would choose Glassfish and then browse to an installation of Glassfish server on our machine. If we've already gotten Glassfish configured, then it'll be available as a selection in this pick list. Choose the Glassfish 4 server, choose Java EE7 version, click Finish. Next, we need to add the Java Server Faces configuration and standard library to the application. We can do this in NetBeans by right-clicking on the project and selecting Properties. Once the project properties is open, click on the Frameworks menu option and then select the Add button to add a framework. Choose Java Server Faces from the selection box and click OK. Lastly, click OK and accept all defaults, which should configure our application for use with JSF 2.2 at this point. Right-click on the project once it is created and choose Open POM and show the POM. Add the PrimeFaces repository as a dependency by right-clicking on the Dependencies section in the project and choosing Add Dependency on OS X, and then type PrimeFaces and choose PrimeFaces 5 repository. Click Add, and then go back to the POM file and see whether it has been added. PrimeFaces can also be added to a project within the Properties dialog. If you right-click on the project and then choose Properties, you can then navigate to the Framework section and add the PrimeFaces framework by selecting it within the Components tab of the dialog. Doing so will add the library to your POM XML. That concludes this brief introduction. In the next video, we'll learn how to develop sophisticated layouts using the PrimeFaces layout component. Welcome back to Pact Publishing's screencast series on mastering PrimeFaces. In this video, we'll examine how to leverage PrimeFaces in order to easily develop sophisticated layouts without the need to rewrite cascading style sheets manually. The usability of an application is often dependent upon an application's layout. Java Server Faces enables one to easily develop an application user interface and even apply the same user interface to multiple views via the use of facelets. The standard JSF components make it easy to create basic application layouts, but they do not offer enough flexibility to provide the ability to develop intuitive layouts that will work in a wide variety of situations. PrimeFaces contains components that help to take the application user interfaces to the next level by adding convenient and easy-to-use components that make it easy to extend upon the standard JSF components to develop a user-friendly application layout. The layout component, in particular, can be useful for placing content on the screen where it makes sense without the developer worrying about writing CSS to build the layout. If we take a look at the PrimeFaces showcase, you can see that there are a number of examples that can be used for determining how to best utilize the layout component for your application. In this video, I will demonstrate how to use the layout component to build a basic user interface, and then we will build upon that basic layout by adding event handling for the different sections of the view. We will also take a look at adding components to the different sections and enabling those components to interact with the components in the different sections of the layout. To get started, let's develop a basic application layout using the layout component to place content into the header and footer regions, the right and left regions, as well as the center of the view. We will begin by developing a single view using the layout, and later we'll see how to translate that same layout into a facelets template so we can apply it to multiple views. Let's open up the Prime Auto Sales application within NetBeans, and we can take a look at the initial API. To begin, let's build and run our application to see what it looks like without any further development. To do so, right-click on the project within NetBeans and select Run. This will start up the registered Glassfish 4 application server if it is not already running, and then it will clean, build, and deploy the Prime Auto Sales application. Our default browser will open, displaying the application index page. Let's modify that initial view by adding the PrimeFaces layout component. First, open the index.xhtml view within the NetBeans editor and add the necessary namespaces for JSF and PrimeFaces, namely, add the HTML, JSF core, and PrimeFaces namespaces. Next, add the PrimeFaces layout component in the body of the view, and after adding the tag, press the spacebar. Note that NetBeans displays a dropdown containing the list of attributes available on the component. By selecting the attributes in the dropdown with the arrow keys, you can see that the documentation for each is displayed in line. The PrimeFaces website or user manual can also come in handy here for determining which of the attributes we wish to use. In this case, let's just choose the full page attribute, which will enable all of the regions for our PrimeFaces layout. Set the attribute equal to true, and then close the tag and add the closing layout tag below it. Now, we'll add some regions to our layout by placing the number of PrimeFaces layout unit components within the scope of the layout tag. Let's add 5 layout unit components, specifying the position attribute for each, and specify their respective positions. In this case, north, south, east, west, and center. Let's add some text to each region so that it will display nicely on screen. Add Prime Auto Sales to the north region, menu to the west region, footer to the south region, content to the center region, and NA to the east region. Now, take a look at the application in your browser, as NetBeans should automatically apply the changes and reload. Note that the layout nicely divides the application view into specified regions. Next, let's apply a few simple customizations to our layout regions. We can customize the regions by specifying various attributes for the layout unit child components. In this case, let's add the collapsible equal true attribute to the west component and the closable equal true attribute to the east. Also, add the resizable equal true attribute to each of those units. Note that when you save the view, the two sections are now resizable, but there is no option to collapse the west unit or close the east unit. This is because it is necessary to add a header to layout components in order to enable this functionality. Add the menu header to the west layout unit and information to the header of the east layout unit. When you save, you will notice that the buttons for closing and collapsing now appear, but they are likely not aligned properly. You can also set the multiple other attributes to further customize each layout unit, such as collapsible, effect to set an animation, etc. We need to set a fixed size for these layout units in order to ensure proper positioning of these buttons. To do so, let's add the size attribute to each of these layout units, and let's set them each to 150. Now, the buttons for closing and collapsing should appear in their respective header regions, and when you click on them, then the expected action should occur. Next, let's see how to apply this same layout to multiple views within our JSF application. In order to do so, we need to create a facelets template that encapsulates the layout for our application. We can then apply that template to different template client views, and customize each view by defining different UI defined sections to incorporate the different content for each view as needed. First, create a folder within the Web Pages project section by right-clicking on Web Pages and choosing New Folder. Name the folder Layout. Right-click the new Layout folder and choose New, Other, and then choose Java Server Faces as the category from the New File dialog, and choose Facelets Template as the file type. Note that on the next screen, NetBeans enables the ability to add regions to our default layout, which can be done by using CSS behind the scenes. We're not going to use this option because we're using PrimeFaces layout instead. Name the file Template and then select Finish to keep the defaults. Open the index.xhtml file, select all, copy, and then paste over the auto-populated content of the new template.xhtml view. Next, add the namespace for Facelets to the file. We can now add templating to the file by adding the UI insert name equal content into the center layout unit. Save the file. Now, go back to index.xhtml and add the Facelets namespace there as well. Remove all the tags within the body and add a UI composition as the outer tag, UI define inside of it as a child, and then add the text auto sales body within the UI define. And also specify name equal content on the UI define. Specify the layout /template.xhtml template for the UI composition tag to make this view a client for the template that we've created, and save the view. The PrimeFaces layout component is now available within the template to be applied to any view in our application. One last topic that I'd like to touch upon is adding a listener to the layout for making a client-side callback on certain events. Specifically in this lesson, I'll show you how to add a callback when the menu unit is resized. There are a couple of different ways to do this, but we'll be making use of the PrimeFaces Ajax tag in this case. This is just a quick example, and we'll cover Ajax in much more detail when we get to section 8. For now, you should know that the Ajax tag can be embedded as a child tag for many components, and server-side listeners can be bound to the Ajax tag, thereby allowing those server-side methods to be invoked when certain events occur. In this case, we will call a server-side method each time the resize event occurs. Up until this point in the video series, we have not touched upon any server-side or managed bean classes to help us coordinate our UI efforts. In this video, we'll create a managed bean for use with displaying the automobile data, and we will use it to help us determine which tabs need to be rendered and when to render them. You should note that at this point, the PrimeFaces is a user interface framework, but it also does contain a server-side API for manipulation of the components within the business logic. It also incorporates a JavaScript API, which we have briefly looked at in the previous section for working on the user interface and event handling in particular. To begin, let's add a JSF managed bean named MainViewController within a package named org.packed.primeautosales.jsf. First, add the new package using NetBeans by right-clicking on the Source Packages folder and selecting New Package. Next, add a new JSF managed bean named MainViewController to that package. To open the dialog, select JSF managed bean or navigate to the Other menu, then go to Java Server Faces and find the JSF managed bean option. In the Manage Bean dialog, let's set the bean to Request Scoped, and NetBeans will add the appropriate CDI annotations to make the bean available via use for the JSF expression language. At this point, it is worth mentioning that we should always be using CDI scopes rather than JSF scopes if working with JSF 2.2 or later. Next, we will add a public method in the MainViewController class. Let's name the method LayoutResizeEvent and accept an argument of type resizeEvent, which is the org.primefaces.event.resizeEvent. In the method, Simply add some text to call upon the resize event to obtain some information and display it. Now, that's all for the server-side method. Open up the template.xhtml file and add the p-ajax tag as a direct child of the p-layout. Specify the event attribute with the value of resize and add the listener attribute assigning the mainViewController.layoutResizeEvent method to it. For this example, let's add a hform tag outside of the p-layout, and then be sure to add the closing hform tag at the end. Save the code, and that's all. Let's run the example, and as you can see, the textual message that we made inside of the new method is printed to the server log each time we resize the layout unit. Once you have finished running the example, remove the hform tags that we added for our demo purposes. This concludes this video in the Mastering PrimeFaces video course. In this video, we covered the PrimeFaces layout component, applied some simple customizations to the component, and added the component to template of our Prime Auto Sales application. In the next video, we'll be covering panels and grouping. Welcome back to Pack Publishing's screencast on Mastering PrimeFaces. In this video, we'll be taking a look at panels and grouping components within panels. In this video, we'll cover the PrimeFaces panel component and learn a few tips about customizing panels. We'll then look at how to group elements within a panel in order to organize a layout. We'll also take a look at some PrimeFaces panels, such as the field set, notification bar, and scroll panel. If we look at the PrimeFaces panel component within the PrimeFaces showcase, we can see that there are a number of features which can be applied to the component in order to make it suitable for the needs of our application. For instance, a panel can contain a header. It can be made toggleable and closable. The header can also contain specialized buttons, and we can add a footer as well. Take a look at the PrimeFaces documentation on the panel component for more details. Next, let's add a panel component and a few different regions to our Prime Auto Sales application so that we can see how it can be useful under various conditions. First, open the index.xhtml file, remove the Auto Sales body text, and add a panel component to the main body in its place. Add a header to the panel and name it Prime Auto Sales by specifying the header attribute. Next, add some text within the panel as follows. Panels are oftentimes used for the organization and grouping of components. As such, we can place just about any component within the PrimeFaces panel. So, let's place an image inside of this panel by adding a graphic image component. Have not already contained images in your library configured within your application, you can do so by creating a resources folder within the web pages root in NetBeans. You can then nest an images folder within the resources and place your images inside that folder. From the available code bundle for this course, copy the images you'll find in the Section 1 folder, and we'll use these images throughout the application. Once that is completed, add the auto1.jpg image by specifying the images library within the graphic image component, along with the name of the image in the library. To be sure that the image fits nicely, add a width of 125 and a height of 100. Let's jump out to the browser now and take a look at our basic panel. If we wanted to make the panel closable and toggleable, we could do so by specifying the respective attributes. Let's do that now. Specify each of the attributes on the panel component, giving a Boolean of true for each. Also, specify the close title attribute with a value of close. Now, let's look at the application in the browser again, and notice that the toggle and close buttons now appear in the upper right corner of the panel. And if you hover over the close button, the tooltip is displayed with the text that we specified for the close title attribute. You can also specify various other attributes to customize your panels. You can even configure how fast you'd like the panel to toggle or close by specifying the toggle speed and close speed. Now that we have the main panel, let's add some auto categories to our main page for our user to select from. The PrimeFaces field set panel component is nice for displaying related data in a panel with a visual legend for the panel. Let's add a few field set components to the application now, and add a label for each one by specifying the legend attribute. Label 1 for car, another one for pickup truck, and another for SUV. Let's make each of the field sets toggleable and set the toggle speed to 300 milliseconds. Add a panel grid inside each of the field sets, and add a graphic image along with some text for each. For the car section, we will add car.jpg. For the pickup truck, we will add pickuptruck.jpg. And similarly, for the SUV section, we will add suv.jpg. Configure each of the images with a width of 125 and a height of 100. Add high-quality text to each of the field sets. Now, let's save the view and take a look at the updated homepage within the browser. Note how each of the field set components has a legend and each are toggleable. PrimeFaces includes a scroll panel component for situations where you wish to allow a panel to scroll in order to accommodate a large amount of data or text. Now, let's add a scroll panel to the SUV field set so that we can accommodate a large amount of text. Add a scroll panel around the output text component within the SUV field set. Let's set the scroll panel to use native operating system scroll bars by specifying the mode attribute with a value of native. Let's also specify the size of the scroll panel by providing a width and a height value for the panel style attribute. Now, let's simulate a large amount of text by adding about 10 to 12 breaks of output text. Let's take a look in the browser now and see how everything looks. Let's now add an action to the SUV field set so that when it's toggled, a message will be displayed. There are a few different ways to add actions to a toggle event, and we'll take the easy way out this time by adding a Ajax tag within the field set to listen for a toggle event, and then perform an action upon it. We'll only briefly touch upon the Ajax tag in this video, as we will cover it in detail in later videos. First, we're going to demonstrate a notification using a notification bar component to display a message. Let's add a notification bar component to the top of the view within the UI-defined element. Set the notification bar position attribute to top and give it an effect attribute set to slide. Next, add a message and a hide button within the notification bar. You can really copy and paste the sources from the PrimeFaces showcase for the notification bar, being sure to paste the hide button component within the notification bar itself. Add the Ajax tag to the SUV field set and set the event to toggle. And we want to fire off the PrimeFaces JavaScript event when the toggle event occurs. So set the onSuccess attribute to PF bar show. Because the widget bar of the notification bar is bar, and we want to show the bar now. Note that the hide button that we've embedded into the notification bar performs the opposite PrimeFaces JavaScript event as it hides the widget. Now load the application in your browser and toggle the field set. You should see the notification bar display the message. When you press the hide button, the notification bar should be hidden once again. In this video, we took a look at various PrimeFaces panel components. We looked at how to add a basic component to the view and how we could apply some customization to that panel. We then took a look at the field set and notification bar panels, adding a scroll panel within each of the field sets. In the next video, we'll take a look at the tab view panel. In this video, we'll be taking a look at the tab view panel. In particular, we'll take a look at organizing data using a PrimeFaces tab view component, and then we'll see how to perform conditional rendering of the different tabs. To get started, let's create a new view named automobile.xhtml, which will be used to display on-screen information regarding a selected automobile. We will use a tab view to display the data in an organized manner. Different tabs will only be visible when certain automobiles are chosen. Right-click on the Web Pages folder and create a new XHTML file. Name the file Automobile and save it to the web root. Select all the markup within the new view and delete it. We are going to copy the code from within the index.xhtml and paste it in as a starting point. After you've done this, remove everything within the Automobile XHTML view that is in the UI-define element. Now, add a tab view component inside the UI-define without specifying any attributes. We are then going to add 3 P tab components within, and each of these represents a tab within the view. Specify the title attribute for each of them and provide a value of information for the first tab, specifications for the second, and four-wheel drive specifications for the third. The last tab is going to be conditionally visible depending upon the automobile selection that is made. Finally, add the same text as a title to each of the tab components for this initial test. Now, let's go ahead and load this view just so you can see what it looks like initially. You'll have to type in the view name into the URL in order to display it using the path faces/automobile.xhtml because we haven't yet wired it up to anything. Next, let's add some navigation to the automobile view. And to do so, we will add a button within each of the field sets that we have added to the initial page of the application for now. Later on, we're going to wire the automobile view up to an individual car, truck, and SUV ads, but we'll perform this initial test to link test functionality. To start, let's modify the main view controller class that we created previously by adding a string instance field identified by selection type. Create the getters and setters by encapsulating the fields within NetBeans. Right-click on the field, choose Refactor, followed by the encapsulate fields. Next, let's add the 3 methods to the controller, each returning a string. Name the first Navigate to Car, set the selection type to Car, and return a string automobile.xhtml. Name the second Navigate to Pickup, and set the selection type within that method to Truck, and return the string automobile.xhtml. Lastly, name the third method Navigate to SUV, set the selection type to SUV, and again return the string automobile.xhtml. On the index.xhtml view, add a command button to each of the fields and set the action for each command button to the respective navigational method within the main view controller class. Be sure to set the Ajax attribute to false in order to submit the form when the button is clicked. Finally, add an hForm element around the entire view, so within the UI declare, add hForm equals main view form. Now let's test it out again to see if we're able to navigate to the automobile view now by clicking the buttons within the field sets. Let's conditionally render the four-wheel drive information tab depending upon the type of vehicle chosen. To do this, we should set the render attribute of the tab equal to conditional, where the selection type is either SUV or truck. We can specify this conditional using a JSF expression language quite easily. Now that we've performed this task, let's refresh the application and test it out. Now that we've seen what the tab view can do, let's take a look at one more way to create a tab view that's based upon a list of objects. Let's create a list of objects for which we will generate a tab view. To begin, let's create a simple object which will only be used for this example. Since that's the case, I'll not worry about packaging it up nicely. Let's right-click on the JSF package and create a new Java class. Let's name it car. From there, define 3 private fields in the car class: make, model, and description. These should all be of the type string. Now, encapsulate the fields to create the getter and setter for each, just as before. Now that we have a basic object that can be used for creating tabs, next open up the main view controller and create the private list car field named automobiles and assign a new array list to that field. Import java.util.list and ArrayList classes. Now create the getter and setter for this field. In the getter method, let's initialize the list by creating a few car objects and setting their values. First, create an object with a make of Juno and a model of Turbo. Next, create an object with a make of Juno and a model of Rocket. Lastly, create a third object with the make of Acme and a model of Jet. Now, add each of these objects to the automobile list. Lastly, returning the list. Now, in this simple example, we're going to use the list to populate a tab view. Let's open up the automobile.xhtml view again and scroll down past the tab view that we previously created. Add a new tab view and set the value equal to mainViewController.automobiles for the data model, and set the var attribute to auto, which will give us a handle on the objects in the model. Now we can create a tab for each of these objects. Within the tab view, create a p tab and set the title equal to auto.make. Within the tab, add a string auto.model, just so we can see some text. And we can also add auto.description if you'd like. Now, when you run the example, open up the automobile.xhtml view again and scroll down to the newly created tab view. You should see that the data model is iterated, creating a tab for each of the objects. This is a nice, convenient way to create a content container for your objects. In this video, we covered the tab view component and some basics around it. We looked at how we could add one or more tabs to a view, and also how we could conditionally display a tab with the help of the back-end business logic and JSF expression language. In the next video, we'll take a look at a similar component, the accordion. In this video, we'll be taking a look at the accordion component and some basics around them. We will also delve into event listeners with the accordion and learn how to tie an event handler to the accordion to determine when a different section is being viewed. To demonstrate the accordion component, we will create an About view, which will be used to display information about the Prime Auto Sales Company. If we look at the PrimeFaces showcase, you can traverse into the Panels section and then select Accordion to see a demo of the component. As you can see, much of the information that we will cover in this video is already being demonstrated in the showcase. Therefore, you'll have a couple of examples to choose from. Let's get started. To begin, add a new view named About.xhtml to our NetBeans application. Next, replace the contents of the new view with a copy of the contents from index.xhtml. Once the code has been pasted, delete everything within the UI define element and add an accordion panel component to the view. Note that the accordion panel accepts the p tab component as its children. Therefore, this component is much like the tab view, but it obviously renders differently and includes some different attributes. I encourage you to play around with some of the different attributes so that you can learn about how they are all differently used. We will look only at a couple of the attributes in this video. For now, let's leave the accordion panel component without attributes and add a 3P tab component within it. For the first tab, add a title of About, and for the second tab, add a title of Contact. Finally, for the third, add a title of Map. Now let's add some placeholder text within each of the tabs and see what it looks like within the browser. Now that we've seen the basics of the accordion panel, let's cover some of the attributes. The active index attribute is used to specify which tab to display on load. The dynamic attribute can be used to specify whether the content of a particular tab should be lazily loaded or if it should be loaded with the view. The on-tab change and on-tab show attributes can be used to specify client-side callbacks written in JavaScript for when a tab is changed or shown, respectively. If we wish to make an Ajax call, the P-Ajax tag can be embedded within the accordion panel, and on the tab change event, it can be used as a trigger. Let's add the tab change event by embedding a P-Ajax tag within the component and specify tab change for the event. When the event occurs, we want to update a message within the view to display some information. Therefore, let's add a growl component to the view, which we'll cover in more detail later. And we'll specify an ID of About message. Now, specify the update attribute of the PAJAX tag and set it equal to About message so that the growl component is updated when the Ajax event is complete. A nice feature of the growl component is that it includes an auto update attribute, which can be set to true in order to automatically update the component with each Ajax request within the form. By setting this attribute, we can eliminate the requirement to use the PAJAX tag to update the growl component. Now, add a managed bean for the About view, and we will place it into the same package as our previous managed bean. This time, name the bean About View Controller and make it Session Scoped. Add a listener method within the About View Controller and be sure that it accepts a tab change event as a parameter. In the method, create a Faces message which displays the title of the active tab. Perform the necessary imports. Specify the listener attribute of the PAJAX and set it equal to About View Controller dot tab change handler. Lastly, let's add some navigation to our About page by placing a form in the West Layout Unit template region, followed by a couple of command links. Set the first link to Home with an action attribute of Index, and set the second link to About Us with an action attribute of About. Build and load the application, test it within the browser. In this video, we briefly looked at the accordion component. We added this component to a view in the Prime Auto Sales application, which will be used to obtain information about the company. We then added a tab change listener to the component, and we wired it up to the backend managed bean to display a message. In the next video, we will look at the wizard component and use it to create a simple entry form. In this video, we'll be taking a look at wizards, which allow one to develop an intuitive interface for a data entry form. In this video, we'll be creating a view that allows our site visitors to sign up for newsletters and add emails. Let's get started. The wizard component allows one to develop a step-by-step data entry form, providing validation for each step so that the user has an intuitive and easy-to-use interface for entering data. The wizard component is comprised of tab components similarly to the accordion panel and the tab view components. Each of the individual tabs represents a step in the flow of the wizard. The wizard component by default displays next and previous buttons, but these can be overridden by specifying a false value for the show nav bar attribute and then creating your own buttons. Similarly, the show step status attribute defaults to true, which displays the current step in the process. This can be set to false to hide the progress. If you wish to create a simple wizard which performs each step in the process every time moving forward, then there is no reason to specify the flow listener attribute. However, this attribute comes in handy if you wish to configure a listener that will be called upon each time the wizard is moved to the next step or back to the previous step. This can come in handy if you wish to skip certain steps if specified conditions are met. The component also contains an onBack and onNext attribute, which allow one to specify a client-side JavaScript event handler for these actions. Create a new view named User Registration following the same process that we had used in previous sections, replacing the code within the newly created view with that which resides within the index.xhtml. Once that is completed, remove everything within the UI-defined element in the new view. Let's create the Java classes to support the user registration wizard by generating a new package named org.packed.primeautosales.entity and generating a class named user within it. We should define the following fields within the class: first, last, age, email, and booleans for newsletter, enable notifications, email notifications, and encapsulate the fields to create getters and setters. Later on, we will actually define this as an entity class and persist the records in the database. For now, we'll simply use the class as a plain old Java object for constructing the data from our registration wizard. Next, create a managed bean controller for the registration view named User Registration Controller and make it view scoped. Create a private field of the type of user and generate a method named getCurrent, which returns you to the current user or new user entity if none yet exists. Now that we have server classes created for our wizard, so let's proceed to create the user interface. Add a form to the user registration view and add a new PrimeFaces wizard component within that form. Provide the ID of user registration wizard for the new component. Next, specify the flow listener attribute with the value of user registration controller.flowHandler. We will generate this method in a few minutes. Next, create 3 tab components within the wizard. For the first tab, provide the title of user registration and then create labels for input text components for capturing the first name, last name, age, and email of our user. Bind the values to the current instance variable for the user registration controller. Lastly, on the first tab, specify a Boolean checkbox field and provide a label for the box displaying Enable Notification. This should be bound to the Enable Notifications field on the current user class. Next, for the second tab, specify the title of Subscriptions and provide 2 Boolean checkbox fields. The first should be labeled Newsletter, and the second should be labeled Email Notifications. And bind these fields to their respective fields within the user class. Lastly, create a third tab with an ID of Confirm and a title of Confirmation. In this tab, simply display the text you are about to register the user, user registration controller.current.email. This will be a confirmation for the user to continue or go back. Next, create the flow handler method within the user registration controller class and provide logic that will skip the second step in the wizard if the user does not enable notifications in the second step. The method should accept the flow event as an argument, and it should check to see whether the current.enable notifications field is set to true. If not, then return the name of the confirmation view for proper navigation to end the flow. If it is true, then return the next step in the wizard by calling event.getNewStep. Lastly, modify the template to add a command link menu option for the new form. Run the wizard and see how it functions. In this section, we learned how to make use of the wizard component and add a flow listener to the component in order to skip steps if needed. This concludes the first section of the video series. In this section, we touched upon various PrimeFaces layout and panel components, including the tab view, accordion panel, and wizard. In the next video section, we'll take a closer look at generating sophisticated user entry forms. Welcome to the second section of the Mastering PrimeFaces video course. In this section, we'll be covering the construction of input forms using the PrimeFaces input components. You'll learn how to use some of the components, lay them out nicely, submit data to a persistence store, and finally, how to validate the data entry. In video 2.1, we'll cover the basics of organizing labels, input components, and messages in a view. To get started, let's create a new view named autoquote.xhtml using NetBeans, and we'll make this view a template client so that it adheres to the template that we've created in the previous section of the tutorial. Create a view by right-clicking on the project in the IDE, selecting New, Other, then select Java Server Faces from the New File dialog, and finally choose Facelets Template Client as the type. Name the file AutoQuote, and then leave the project folder and created file fields as default. Next, for the template field, let's browse to the Facelets template for our project and select it. Then leave HTML as the generated root tag. Click on Finish, and the new view should be created with an empty content area. We want to add a nice title to the form along with a brief description. Therefore, let's add an H2 header to the top of the content section, followed by a paragraph containing the brief description. Next, let's add a couple of line breaks after the paragraph before we start our form. Next, add a form element to the view and provide an ID of AutoQuote form. Note that we do not have the appropriate namespaces in the view by default, so we'll have to add the JSF and PrimeFaces namespaces next. To do so, let's go to the top of the view, add them, or in this case, I'll use NetBeans tip to add the necessary namespaces as the errors appear in the form. Next, we need to add labels and fields for our form. And let's begin by adding some details for our user to fill out by themselves. Particularly, let's add the first name, last name, phone number, and email address at which they can be contacted. We can use a standard HTML label element to assign a label to each field, or we can make use of the PrimeFaces output label component. In either case, ensure that you provide the for attribute of either and assign them to the appropriate input component ID. In this case, I'm going to use the output label component so that we've got a pure JSF form. We'll use the standard PrimeFaces input text components for the first and last name components. For this iteration, let's go ahead and just add a line break between each label component pair. For now, let's go ahead and leave the value attributes empty as we will bind these fields to an entity class in the next section of the tutorial. Let's make use of the PrimeFaces input mask component for the phone field. To use this component, you need to add a mask or pattern for the user to enter. The user will be forced to adhere to the mask format. In this case, we'll provide a mask for a telephone number using the 9 to signify a digit. A mask format forces a user to adhere to the pattern that is supplied by the mask. For instance, if we set up a mask format for this phone number, then the user will not be able to enter anything into the field besides a number, and the mask will also require the user to enter a specific number of characters. In this case, the mask will supply the dashes and require the user to enter 10 digits. Other mask characters can include symbols, upper and lowercase a, and an asterisk for the wildcard. Finish completing the input form by adding input text components for the make, model, and year, a text area component for the description, and a calendar component for the required by field. Utilize the PrimeFaces output label to provide a label for each field. Doing so ensures the theme-based scanning for the validation errors, among other things. Let's leave the command button off for now until we wire up the back end. Go ahead and run your application, and let's take a look at the resulting output. As you can see, it's not very well laid out. Let's go ahead and add a panel grid component to help with our form layout. A panel grid will render an HTML table at runtime so we can specify how many columns we would like to use for this grid. Since we are building an input form with labels and components, we should specify a column for each. Ideally, we want to have the same spacing between each component so that the form looks visually appealing. In this case, let's add 2 columns by specifying a 2 for the columns attribute. Next, we'll need to remove the BR tags as the panel grid is only going to be set up for displaying 2 columns, and each of the JSF components will take up one of those columns. Therefore, we need to make the number of components or tags within the panel grid match the number of columns that we have specified. When we save our application and reload, then you can see that the form is aligned nicely. That does it. You should now understand the basics of form layout for JSF and PrimeFaces applications. In the next video, we'll take a more in-depth look at the basics of construction for an input form, including data persistence and wiring the components to the back end. In this video, we'll learn how to wire up to the input form elements that we've laid out within the user registration form so that we can persist the data when the form is submitted. We'll learn how to create an entity class and bind it to an instance within the Managed Bean controller. Let's get started by taking another look at the user registration form. If you'll recall, we developed this form in the first section of the video course, and it was a form that was created using the PrimeFaces wizard component. We bound the action attributes of the form to an instance of the user class that resides within the user registration controller Managed Bean. In section 1, we did not create an entity class for the user. Instead, we merely developed a POJO. In this section, we will annotate a user class accordingly and make it an entity class. We'll also create the prime user table within the Apache Derby database. So we will get this legwork done before moving on to constructing the front end using PrimeFaces input components. Let's start out by developing the database table. We can create a script within the NetBeans IDE for the Derby database using the create table statement to create the prime user table. Go ahead and open up the sample database that is installed by default with Apache Derby by clicking on the Services tab within NetBeans, and then expanding the database node. There should be a sample user already created, and you can double-click on it to obtain a connection. Note that you may have to right-click on JavaDB in order to obtain your connection, depending upon the version of NetBeans that is in use. Right-click on the database connection and select Execute Command, which will open up the SQL editor. Let's type in the create table statement for the prime user table. Once you have it typed out entirely, execute the statement by clicking on the green arrow. If you would rather use a GUI to create the table, then you could do that as well by right-clicking on the table folder and selecting Create Table and entering the name, data type, and size of each field. The user table should now be created, and we can go ahead and annotate the user entity class accordingly. And then we can create our persistence unit and map it to the sample schema. Open up the user class and note that there is a field-to-field mapping between the user class fields and the prime user database table, with the exception of the ID field. Place an entity annotation before the class signature to mark this class as an entity bean, and add a name attribute specifying prime user string to map the entity class to the prime user table. Next, go ahead and add that ID field to the user class now as a big decimal type, and apply the ID annotation over it to mark it as the primary key. Next, use NetBeans tooltips to import the required classes. Next, annotate the first field with the column annotation and specify the corresponding database field name, which is optional if the column names are the same as the field names. Follow suit for each of the other fields. Lastly, there should be a NetBeans tooltip next to the class name. Click on it to create your application's persistence unit. Now, although PrimeFaces is a UI framework, I'm covering this feature just so you can set up a database to persist your application data. Rather than creating a dummy application that does not store any actual records, I'd prefer that you have an actual working application in the end. When the Create Persistence Unit dialog appears, shorten the name of the unit by making it Prime Auto Sales 1.0 snapshot PU. Next, keep all of the other defaults, and finally, click Create. Once the persistence unit is created, open it up and modify a couple of elements. Now that we've gone through the steps to produce the database table, entity class, and persistence unit, let's move on to the action method behind the input form and then the actual form itself. To complete the basic input form, we need to add a command button to the form, which links back to the backend method to persist the data. Let's add a new session bean for the user entity class by right-clicking on the source packages and adding a new package. Let's name the new package org.packed.primeautosales.session. Next, right-click on the newly created package and choose New Session Beans for Entity Classes, and then select our user entity from the dialog window. Now, retain all of the defaults for the remaining wizard screens and click Finish. We now have an EJB that can be used to perform the actions against our user entity. I do not want to go into any further detail on the EJB, so let's keep this just as an overview. Go to the user registration controller and inject the EJB so that we can make use of it. Again, keep in mind if you're not familiar with EJBs, it's not a big deal. This is just one way to access the database so that we can work with the data for these examples. Other means could be a web service or simply arrays of data. Once you've injected the EJB for this example application, resolve all imports. Next, add a create method to the controller, which we will bind to our command button in just a minute. The create button should be a public method, which will call our EJB's create method within the implementation, passing the current user instance. Let's return a null for now and keep the user on the same view after the button has been pressed, as no navigation will occur. Now, let's go to the user registration view and add a PrimeFaces command button component after the wizard. Let's add the create user label to the button by supplying that as a value attribute of the component. We'll add an ID of create user to bind the action attribute to the create method of the user registration controller. We can now run our application, provide some input, and then click the button to create our user. Note that you will not see any feedback after pressing the button. That's because we need to add some notifications to the view, which we will do in the next section. We've now generated a database entity for the backing of our user registration form. We've also added a command button to the form, which will be used for submitting the new users to the database. Next, we'll look at providing some useful feedback to the user when the button is pressed. In this video, we'll add some feedback for the user when they click on the Create User button in the user registration form. As it stands, when the button is pressed now, there is no feedback whatsoever. To provide the feedback, we will utilize one of two PrimeFaces components. First, we'll look at using the message component to provide a message for the user once the button is pressed. And second, we'll look at using the more sophisticated growl component to provide some feedback. Let's get started by adding some back-end code to display a useful message. Let's start by adding some code to our create method, which will result in adding a success message to our faces context. We can then display that message to our user via the help of some PrimeFaces messaging components. Go to the user registration controller class and add a faces message call to the create method. We can do this in one line of code by obtaining the current instance of faces context and then adding a message to it. we want to add a new Faces message instance, and we want to label that message as informational. We could choose to label it as error, fatal, info, or warn. Let's simply add the text as successful user entry as a message. Note that we're typing this message twice because once is for the summary message and the second is for the detail message. We could add more information to the detail message if we wish to do so. That's all for the message. We're simply counting on our create method to work and return a successful message to our user. We also need to be sure that we're populating the ID of the current user record with the next number in the sequence. So let's add some code to grab the next number greater than the current number of records in the prime user table. Next, let's add the PrimeFaces message component to the front-end view. Open the user registration form and add the p-messages component directly above the p-wizard component tag. Let's add an ID of user registration message and set the show summary attribute to true. Let's take a moment to see how well NetBeans is bound to the PrimeFaces user documentation for providing attribute feedback. Simply press the spacebar after adding the messages component to see a list of attributes. You can then press the down arrow to scroll through the attributes and return the documentation for each. Once we've added these two attributes, close the tag. Next, let's add a break after the messages component so we can make it look a bit more visually appealing. Lastly, let's run the code and see how it works. First, add some data to each of the fields in the wizard. Next, click on the Create User button. After clicking the button, you'll notice that nothing happens. This is because we need to refresh the messages component after the Create User button action has completed. To do so, let's modify the PrimeFaces command button by adding an update attribute and specify the ID of the messages component. Now, try to add another user and we can see that the success message is now displayed nicely. Next, let's add a growl notification to replace the standard PrimeFaces message component. To do so, edit the user registration view and remove the p-messages component. Let's replace it with p-growl, and we'll keep the rest of the attributes the same. Now, submit a new user record, and you can see the difference between the growl and messages component, as the growl displays a nice pop-up notification that dissipates after a few seconds. Let's quickly run down some of the more useful attributes of the growl component. It is useful to know that you can set attributes such as life to determine how long the growl component is displayed before it disappears, and sticky to specify if the message should stay within the view, rather than dissipating after the life expires. You have the option of styling the messages differently depending upon the level of severity by specifying the severity attribute and providing a value of error, info, or warn. Note that if you wish to include any HTML within your growl message, you must specify the escape attribute and set it to true. The growl component is very customizable, and we'll dig deeper into the customizations at a later point in this video. In this video, we completed the recipe for generating a fully functional user entry form, complete with database persistence. You saw the difference between the PrimeFaces messages component and the growl component, and you also worked a bit more with the PrimeFaces wizard component. In the next video, we'll add some validation to our user entry form so that invalid data does not make it into the database. In this video, we'll take a look at adding some validation to an input form. Specifically, we'll be adding validation to the user registration form so that invalid data is not allowed to pass into the database. We'll first see how to add messages for each individual input component. Next, we'll change the components themselves to provide a quick validation. We will then look at a more sophisticated client-side validation using PrimeFaces client-side validation. And finally, we'll apply a server-side validation using the Bean validation framework. Let's get started. Before we can add validation to the view, it's a good idea to lay a foundation for displaying feedback to our users. There are a couple of different texts that we can take to display feedback for the user. We can add a view level message, such as the one that we demonstrated within the 2.3 video. We also have the option to add a component level message, which are certainly useful if there are one or more components that fail validation and require user intervention. In this section, we'll add a messages component to each of the input components in the user registration form, with the exception of the Boolean checkboxes. To add a message, we first need to change the size of our panel grid component, as it is currently sized to show two columns of data, the label and the component. We want to add another column to display a message, so change the number of columns attribute on the panel grid in the user registration tab to 3. Next, add a p-message component to the first name field directly under the first input text component. Specify the for attribute and assign it to the first component. Let's do the same for the other components within the user registration tab. Now, let's run the application again, and you can see that it looks fairly similar to what it looked like before adding the message components. Okay, at this point, there are no messages to display for any component. Let's go ahead and change some of the input components themselves to add a level of validation. Change the first component by adding the required attribute and provide a value of true. Also, you can specify a required message attribute to display a custom error message if the field is not populated. Let's go ahead and do this for all the input components on the user registration tab. Once you've added the required validation checks, then load the application and clear all the fields on the user registration form. Now, try to click on the Next button, and you'll see that all the fields display an error message. Congratulations, you've successfully provided useful feedback to your user by adding just a few PrimeFaces components to the view. Next, let's add some more granular validation to the first and last fields by specifying a minimum of 2 characters for each. To do this, nest an fValidateLength tag and specify the minimum attribute with a value of 2. We'll do this for both of the fields. Now let's test the application by adding a single character to the first field, specifying a full last name, and leaving the other fields the same. Click the Next button and note that the error message for the first field now specifies that we have not met the minimum amount of characters for that field. Now let's add a minimum age by specifying the fValidateDoubleRange tag as a child of the age component, and provide a minimum attribute with a value of 18. After we've done this, let's try to run the form again with an age less than 18. Now let's specify the fValidateRegex tag as a child of the email component and specify the pattern attribute with a value that equals the pattern for an email. Now try to specify some random string that does not match a valid email string for that field, and an error message will be displayed. There are a number of client-side validation tags that can be used, and we've only merely scratched the surface. I suggest you look up more information on the others. We can also use a standard JSF validator along with the PrimeFaces components, but it is out of the scope for this video. In a moment, I'll show you how to bypass the client-side validation using the fValidateBean tag so that we can force bean validation instead. Now, let's add some server-side validation specifying similar validation criteria at the entity level. To do so, we will apply bean validation constraints in the form of annotations on the entity class level. Open the user entity class and annotate the first field with size min equal 2, and add a nice message for the error using the message attribute of the annotation. Next, do the same for the last field. On the email field, let's supply the pattern annotation, providing an attribute of regex with the correct pattern for matching an email address. We will also specify a nice error message by displaying the value that the user entered back to them using the EL string interpolation, new as of bean validation 1.1. Lastly, add the min value equal 18 validation constraint to the age field and specify a nice error message if the value is not equal or greater than 18. Now, you'll never actually get to this level of validation if the client level validation does not fail. So to test, let's remove the client-side validators from a couple of the components on the user registration view, and let's test again. We can also specify the fValidate bean tag if we wish to defer to bean validation instead. It is useful to contain both client-side and server-side validation because if for some reason the client-side validation fails, perhaps a new view never gets rendered completely due to network latency, then server validation will be there as a backup. Lastly, I'll demonstrate how you can force the utilization of bean validation at the component level by embedding the fValidate bean tag within your PrimeFaces components, or enclosing a group of components with the tag. For instance, remember, when we do not specify at least 2 characters for the first name field, we are returned with a generic error message. If we open up our user entity, we can see that the first and last fields are annotated with bean validation annotations, and there are some more user-friendly messages specified here. We can force the first name field to use bean validation rather than client-side by embedding an fValidate bean within the first name input text field. Now that we've done that, run the form again, and you'll now see our nice user-friendly message as opposed to that technical message that was still in place for our last name field. In this video, we completed the client-side validation as well as server-side validation for a user entry form with PrimeFaces components. It is always a best practice to apply some sort of validation to your forms to ensure data integrity, and even better to supply both client and server-side validation. This concludes section 2 of the Mastering PrimeFaces video course. You should now have a good understanding of how to construct a user entry form, commit records to a database, and supply form-level validation using JSF and PrimeFaces components. In the next section, we'll be learning how to display the data that we have entered and also how to edit it. Welcome to the third section of our Mastering PrimeFaces video course. In this section, we'll be looking at different components that allow us to work with lists of data, both for viewing and editing. In video 3.1, we'll learn how to create a basic data table for displaying data. The PrimeFaces data table is a robust JSF table component, which can be heavily customized according to the needs of your specific application. Moreover, it is easy to use and fun to work with. First, let's create a set of data that we can use to display within our data table component. What we'd like to do is create a table to list each of the registered users of the Prime Auto Sales application. If you'll recall from the previous sections, we've developed a user input form which allows one to register for receiving notifications and newsletters from the application. We'll now display those users via a list, and we can now generate that within the user registration controller class. Let's get started. First, open up the user registration class and provide a private field named user list of type list. Specify a generic type parameter of user to ensure that only user object types can be stored. Now, let's make this field accessible to other classes and views by generating getters and setters. In NetBeans, I'll go ahead and I'll right-click on the field identifier, then choose Refactor, and finally, Encapsulate Fields. Then we need to populate this list with the users in the database. There are many ways to do this, but for now, what we'll do is simply create a method named populateUsers and implement the population of the list within it. We'll simply use the EJB findAll method to return all users. Now we need to wire up this method to an action point so that it is invoked to populate the list, which we'll be using for our data table component. Let's go ahead and generate a new view, and since this view is going to be used by the administrators for the site, we'll create a new folder named admin at the root level of our web application. And then we will create a view within that folder. Let's name the view current users. Again, to create this view, we right-click on the folder and then add a new XHTML file, as we've done previously. Now let's go ahead and open up the index.xhtml view, select all, and copy it. We are then going to copy the code in this view to the newly created view as a starting point. And then we'll remove the content of the view and add our data table. However, we have to make one change to the template by specifying the new path since we are inside the admin folder now. Simply add the ... to the front of the path to tell the runtime to go up one level to find the layout folder. Now that we have a blank template to work from, let's add some content. First, let's add a simple identifying header, current registered users. Next, let's add the data table component to the view, giving it an ID of registered user list. Set the value attribute of the table equal to the list that we generated within the user registration controller by specifying an expression that will be used to populate the table with the contents of the user list. Now we need to have a way to get a handle on each individual entity record within the list, so we add the var attribute of the data table, and let's specify user to identify each individual record. That's it for now. It's time to add some depth to the table by adding individual columns. The PrimeFaces data table makes it nice and easy to specify column headers and values in a single element by using the P column component. Let's add a column, and we will provide an ID of first name and a header text attribute of first. The header text attribute is used to display the column header. Nested inside of the column, we will add the output text component and provide a value of it and an expression indicating var.first, meaning that we want to display the first field of the current user record. Note that it really helps if you use a good IDE for developing content such as this. NetBeans IDE is an excellent IDE for using autocompletion, even at the individual data table record level. You can see that when I am typing the user, all the available user fields are showing up in the pick list. Let's follow suit by adding 3 more columns: last, age, and email address. This will complete the data table for now. We will come back to the table and customize it a bit later. Now that we have the data table set up, we need to populate it by invoking that populate users method that we created in the user registration controller class. We can do this by specifying a JSF view action upon view loading. The view action component is new as of JSF 2.2, so you'll need to be using Java EE 7 in order to be using this feature. If you are using an older release of Java EE, you can most likely use the JSF pre-render view solution instead. Let's add an F metadata element to the top of the view, and we'll embed an F view action within it. For the action attribute of the view action, specify an EL expression and call upon the populate users method. This action will be invoked upon the initial request and not on post back. Now that we've developed the view and backend logic, let's check it out. First, let's make a convenient way to access our newly created view by adding a link within the menu of our application. To do so, open up the template and add a new command link to specify navigation to the new view. Now let's run the application and click on the newly added link. Our current user list should be displayed. Note how the data table component is nicely styled by default, providing different colors for odd and even rows. Also, the headers are styled nicely, and we haven't even customized the table yet. One thing to note about the newly added link in the menu is that we will now break the other links since we are in the admin folder with this view. We will need to repair those menu links later by adding a JSF navigational action method and programmatically specifying the path to the appropriate view, or by using navigational cases within the Faces config file. It's also possible to create a lazy data model for loading the data to the data table in a lazy manner. This means that not all the data will be loaded at once, which can help increase performance, especially with larger data sets. To implement lazy loading, you must specify the lazy attribute and set it to true. You must also bind an org.primefaces.model.lazyDataModel as the value for the table, and implement a load method within the data model. This lazy data model can be implemented as a standalone class, which extends the lazy data model parameterized over the object that is being used to populate the table. In the case of this example, we extend a lazy data model using generics with a user object. The second option is to create a bean that will be used to load the table and implement a loading mechanism and lazy data model within it. Assign the lazy data model as a data source for the data table and you're good to go. For this case, let's create a new package and name it org.packed.primeautosales.bean and add a new class named lazy user model to it. This class will, in fact, not be used to encapsulate lazy users per se, but rather it'll be used to load users into the table in a lazy fashion. Extend the lazy data model user in the class, and then create a private list user field named data source. Now, create a constructor that takes a list user as an argument and uses it to populate the new data source field. Next, let's create a load method, of which I will not go into much detail for this session since it can be fairly complex. The load method should accept the following arguments: int first, int page size, string sort field, sort order, map, string object filters. Within the implementation, simply iterate over the data source and load the data accordingly. As mentioned a moment ago, we could go into depth here and filter data somehow, but here we'll remain at a higher level for the purposes of this video. Also within the method, we could implement a sorting algorithm. Typically, one could call upon collections.sort and pass the data along with a lazy sorting class, but we will not do that for this example. Lastly, set the model row count. Next, we need to implement a getRowKey method which accepts a user object as an argument and returns an object. Here, we will simply return the user's ID. Lastly, implement a method named getRowData which accepts the string argument and returns a user object. The implementation will traverse over the data model and return a matching user ID. Now go back to the user registration controller and create a new class field of type lazy data model and name it user model. Next, in the populate users method, let's comment out the original implementation and set the user model equal to a new lazy user model and pass in all the users from the EJB call. Lastly, let's open the current users.xhtml view and set the lazy attribute on the data table to true. And then set the value equal to user registration controller.userModel. Now when we run the code, the model is going to be loaded lazily. Again, we can get in much more granular detail with our implementation if we wish, but this should get you going along loading your data lazily. That's it for the default data table component. In this section, we looked at adding a simple data table component to a view and wiring it up to be populated with entity data. In the next section, we'll take a look at how to make this table editable at the row level. Welcome to video 3.2 of the Mastering PrimeFaces video course. In the previous section, we generated a basic data table component and populated it with data from the user entity of our application. Specifically, the table is used to list the currently registered users of the Prime Auto Sales application. In this video, we'll take a look at editing data records by clicking them by row in our table. When we start to think about how we're going to edit data, we really need to think about how are we going to make it easy for our users to complete this task. I'm sure that you must have seen terrible user interfaces in the past, interfaces where there are cluttered user input forms or forms so large that they are almost impossible to complete. We want to create a concise and easy to use interface so that editing data within our application is a breeze. The PrimeFaces data table can facilitate easy editing, allowing us to create a button at the row level which can be clicked to edit the row data. This brings forth another user interface concept that we need to think about: how to display the data and edit it. In this section, we will indicate that a row of data is editable by changing the table fields to input text components when the row is selected. In order to make this a user-friendly interface, we also need to update the contents of the table after the changes have been made so that the most recent updates are reflected. We also need to provide a confirm and cancel button so that the user can confirm the edits or cancel them if they choose. Another type of editing interface could be a dialog, whereby when a user selects a row of data, it is displayed in a pop-up dialog for user edit. I'm sure there are even more ways that we could create a nice interface for editing. Be imaginative and choose the best interface for your application. Let's get started by making each row in the table selectable. Let's start by going to the view and adding a new column, which will be used for containing the edit controls. Open the current user's view and add a new column to the data table. Specify the text edit for the header text attribute. PrimeFaces contains a component that is specialized for use as a row editor control. We will add the row editor component within our new column. No attributes need to be specified. Now that we've added the row editor component to the data table, we need to specify which components will be used to edit each of the column fields. We can do this by embedding a PrimeFaces column editor component inside each of the columns of the table. The cell editor component makes it possible to specify both an output component for displaying the column content as well as an input component when editing the column content. Let's start with the first column and add a cell editor component, then specify F_facet and provide the name of output. Embed the H_output text component for displaying the first name data inside of the facet. Add an other facet inside of the cell editor component and this time specify input for the name attribute. Embed an input text component within this facet for use when editing the data and provide the same value as the output component. Let's follow suit and add a similar component to the last name column, providing both an output and input component for use with editing. For the H column, let's use a spinner component, which enables one to step forwards or backwards through numbers. Lastly, we'll use another input text component for the input of the email address. Now, we need to enable editing within the data table by specifying the editable attribute and setting it to true. Next, we need to add the ability to invoke a backend action method when the row is being edited. This method will contain logic for persisting the edited data and also for displaying useful feedback to our users. To invoke this action, we need to add some Ajax calls to the data table. We can do this by embedding some PrimeFaces Ajax tags within the data table, and we'll set the events to row edit and row cancel to accommodate the respective editing action. The Ajax tags are responsible for making the necessary managed bean action callbacks when the actions occur. Let's embed the first p_ajax tag inside of the data table and specify the event attribute. Let's set that equal to row edit. This action will be invoked when a row is edited and the submit icon is pressed. We want to invoke a backend method when the row edit event is invoked, so let's specify the Ajax tag's listener attribute and set it equal to the expression user registration controller dot row edit action, which we'll generate in a moment. Lastly, once the row is edited, we want to update the table data to provide the user with some feedback. Therefore, we need to add a growl component at the top of the form and specify an ID on the growl component of current users form messages. We will then set the update attribute of the p_ajax tag to current users form current users form messages so that the growl component is updated when the Ajax event is completed. Next, let's add a row edit action method to the user registration controller class. To do so, open up the user registration controller class and add a public method that returns nothing and accepts a row edit event as an argument. Go ahead and use the NetBeans tooltip to perform the necessary imports. In the method, we will persist the changes that have been made by calling upon the row edit event argument's getObject method, which we will cast to a user object. This object contains the edited row data. We will then persist this user object by calling upon the EJB edit method and passing the object. Next, we'll create a message to display to the user by generating a faces message and add it to the faces context. To do this, call upon the faces context.getCurrentInstance method, then call upon the add message method, and finally pass a null, which is an optional component ID value, and the faces message instance. Now that we've developed the view and backend logic, let's check it out. Load the table and click on the Edit pencil to edit the first row. Change the age by selecting the up or down arrow, and when you're finished, click on the check icon that is in the Edit column. This will invoke the Edit event. If everything is wired up successfully, then you will see the growl component is updated with a success message, and the database will contain the newly changed age. In this section, we learned how to make a data table editable at the row level. In most applications, this type of row level editing will suffice. However, in some cases, it makes sense to edit a data table by cell. In the next section, we'll look at how to edit a data table by the cell. Welcome to video 3.3 of the Mastering PrimeFaces video course. In the previous video, we provided a demonstration of how to make a PrimeFaces data table component editable via row-level editing. Sometimes you need more of a spreadsheet editor, and in those times, it makes sense to utilize cell-level editing on a table. In this video, we will alter the data table that had been worked on in the previous sections, and we will make it editable at the cell level. Let's get started. The idea and implementation behind making a data table editable at the cell level is very much the same as a row level implementation. We need to configure a few attributes on the data table itself, make each of the columns editable by specifying the cell editor component and providing an output and input component for each, and also provide an Ajax action method to be invoked within the managed bean controller when a cell is edited. What is different is that we no longer need to require an edit column on the table, so we can remove that, and the action events are different. So instead of invoking an Ajax action on row edit, we will invoke it on cell edit. So let's open up the current user's view and alter the table from row level editing to cell level editing. The first thing we need to do is change the data table by adding edit mode attribute and specifying cell for this value. By default, the edit mode value is set to row. Next, you can see that we already have embedded the cell editor component into each of the columns within the table, providing an output and input component for each data field in the table. For more information on using the cell editor component, please go back and watch video 3.2. Lastly, go ahead and delete the last column in the table, which was previously used for containing the edit controls. Okay, that should do it. The data table structure is now set for cell editing, but we need to provide an Ajax action method for invocation when a cell is edited. As you can see, we had previously specified the pAjax tag within the data table for row edit event, and we will now change that to a cell edit event. So we also want to change the listener method to user registration controller.cellEditEvent. Now, we need to provide an implementation for the cell edit event. So let's go to the user registration controller and look for the row edit event action method. Let's go ahead and copy that method and paste it directly under the original and rename the method as cell edit event. We also need to change the parameter that is received from the row edit event to a cell edit event. Let's change the method implementation to compare the old cell value to the new cell value and display a message if the value is different. The cell edit action object makes the old value, new value, and column available to us. So we'll also need to figure out which column is being updated and then edit the appropriate field in the user object when an edit is made. So let's create a field for the old value and one for the new value as well. And then we will capture these values by calling upon the cell edit mode and then finally compare these two values. To compare the values, we will use an if statement and first check if the new value is null. Then if it isn't, we will check to see if it is equal to the old value. If it is not, then we will display a message that contains the column header, which we will grab from the cell edit event object along with the new value. Now that we've developed the view and backend logic, let's check it out. Load the table, click on a cell and edit a value. After editing a value, move to another cell, and you should see a message displayed that states that the column which was edited along with the new value. If we do not edit a cell value, then no message will be displayed. In this video, we learned how to make a data table editable at the cell level. This can be useful when the requirement for a more spreadsheet-style editing is essential. In the next video, we will take a look at some of the advanced data table features such as sorting, reordering columns, and hiding columns. Welcome to video 3.4 of the Mastering PrimeFaces video course. In the previous videos of section 3, we've been working with the PrimeFaces data table component. We have implemented some basic features and applied editing capability to both the row level and cell level. In this video, we will delve into a handful of the more advanced data table features, including sorting, reordering of the columns, and having the ability to hide certain columns from displaying on the screen. First, let's make the data table column sortable by specifying the sort attribute on each of the columns. The sort attribute accepts the field to be sorted by as its value, and it automatically applies the default sorting algorithm to the column. Let's add the sort by attribute to the first column, specifying the field by which the column should be sorted. Let's follow suit, and we will apply a sort by attribute to each of the other columns as well. Now, let's take a look at the view after saving the changes, and we can see that the headers of the table columns are now clickable, and when you click on the header, the column data becomes sorted. On the first click, the records are sorted in ascending order, and on the second click, they're sorted in descending order. Now, there are a couple of important things to note about sorting capability. First, it is important that you are setting the data table value equal to a collection within the managed bean. The collection in this case is a list of users, which must already be populated. The sorting is applied upon that collection. So, if you set the value of the data table equal to a method that returns some records from the database, then the sort by attribute will not work. Also, in some cases, it is handy to specify a column sort function, perhaps if you are sorting data of a custom type. In such cases, you should implement the custom sorting algorithm within the controller method and then specify the sorting method using sort function attribute of the column component. That does it for this brief overview of sorting. Hopefully, you can see how beneficial this customization can be and how easy it is to implement using PrimeFaces. Next, let's look at how we can dynamically resize the columns of a data table. This is a feature that is really much like that of a nice spreadsheet, providing the ability to make a column wider or less wide by dragging the column divider. To implement this feature, simply apply the resizable columns attribute at the data table level, specifying true to enable the option. Then, let's go ahead and test the functionality on the view. You can witness after we reload that the view we see has arrow indicators that are telling us that we can resize the columns when we hover over the column dividers. When we drag, the column is resized accordingly. We can apply finer grain control over the column resizing by applying the resizable attribute to each of the column components now. The resizable columns attribute must be specified at the data table level in order to use the resizable attribute at the column level. Of course, the default value of resizable is true, as we can resize any of the columns by default after applying the table level attribute. However, if there was a column or subset of columns that we wished to restrict from resizing, then you can specify the resizable attribute at the column level and provide a value of false. Let's apply this constraint to the last name column, and then we will go to the view and test. As you can see, the last name column is not resizable now. It is also possible to apply a listener to the data table to listen for column resize events. We may wish to do this in order to store the newly resized column width as a user preference. To do this, add a Ajax tag and specify the event of col resize. Next, add a listener attribute to the tag and bind it to an action within the controller class. Let's name this action col resize action, which we will implement next. Finally, add the update attribute and specify the message component to be updated after this event occurs. Now let's go to the user registration controller class and add a new public method named col_resize_action without a return type. We will specify a column resize event object as an argument to this method and apply imports as needed. Inside the method, let's simply create a new faces message and we'll display the current width of the column by calling upon the column resize event object's getWidth method. Now let's test it out, and you can see that when we resize a column, a message is now displayed with the resized column's name and width. Next, let's demonstrate how we can make data table columns and rows reorderable by dragging them around. This is as easy as specifying the draggable columns or draggable rows attributes at the data table level and setting them equal to true. Let's specify the draggable columns attribute on the current user's view data table, and then let's reload the view in the browser and test. As you can see, I can now drag the columns into a different order if I wish. We can do the same for the rows if we specify the draggable rows attribute at the data table level. Just like the resizable feature, you can also specify a table listener using the Ajax tag. We're not going to do this now, but if you wish to do so, simply specify an event of col_reorder or row reorder, and then apply a controller method as the listener. The action method should accept a reorder event object as an argument in order to work with the data. Go ahead, give it a try as an exercise. New in PrimeFaces 5 is the column toggler component. This component allows one to specify a list of columns for the data table along with a checkbox next to each column to indicate whether or not the column should be displayed. Let's add this column toggler component to the current user data table. To do this, we're going to need to add a header to the data table that we're using. This is easy to do by specifying a facet for the header and providing the name attribute with the value of header. Of course, this facet is embedded within the data table. We should supply a table name in the header, so let's add the text current user list inside of the facet. Next, within this header facet, we're going to add a button for the column toggler, as well as the column toggler component itself. The command button will trigger the column toggler. Let's add the command button and specify an ID of col toggler, a type of button, and a value of columns to display the column's text. And we will specify a style of right so that the button floats to the right. And we'll apply an icon to the button by specifying the icon attribute and providing one of the standard PrimeFaces icons. In this case, let's specify UI icon calculator as the icon. Next, add the column toggler component to the facet and specify the data source as registered user list, which matches the ID attribute of the data table. Next, specify the trigger attribute of col toggler because the trigger for this column toggler component is the command button that we previously added. That's it. Let's go ahead and we'll save the view, and then we're going to reload the view and test. As you can see, when we uncheck the column name, it disappears from the table. That wraps up our coverage of advanced data table features. There are much more to learn about, and I recommend visiting the PrimeFaces showcase. And just go ahead and take a look at each of the customizable options. There are plenty of great ones. Far too many to cover in this video course. Up next, we'll take a look at the carousel component, which applies a different spin on the idea of a data table. Welcome to video 3.5 of the Mastering PrimeFaces video series. In this video, we will cover the PrimeFaces carousel component, which provides a way to display entity records in a more visual manner. Let's take a moment to see what this component looks like in the PrimeFaces showcase. As you can see, the carousel component lists entity data in different panels. The carousel component provides a forward and back button for scrolling horizontally through more records. The carousel has the ability to accept different components as children in order to display data in the format that you desire. In the PrimeFaces showcase, the basic component is using a panel grid to display the content in an orderly manner. If you select the Next button, you can see that the records slide to the left and display another set of data. Let's go ahead and implement the carousel component to display auto records within the Prime Auto Sales application. To begin with, we need to define a data set to display in our carousel. We are going to define a database table to hold the automobile data. Since we have already gone over how to construct a database table in the Derby database back in video 2.2, I will not go over that detail again. Instead, if you have not already created the Prime Automobile database table, please do so by executing the SQL script within the create database.sql script. Also ensure that you execute the insert statements to populate the database with a handful of automobile records. Once the table has been created, then utilize the NetBeans wizards to generate the entity class for the Prime Automobile database table. To do so, right-click on the project's entity package and select New Entity Class from Database. Ensure that you have the correct database connection selected, and then you should see the tables within the sample database listed on the left of the New Entity Classes from Database dialog box. Select the Prime Automobile table and then click Finish. Now open the newly created Prime Automobile entity class, and you can see that it models after the database table. We will display instances of this entity, aka database records, within the carousel component. Now, we need to create an EJB that can be used to perform actions against the newly created entity. To do so, right-click on the project's session package and select New Session Beans for Entity Classes. Select the Prime Automobile class from the list and click on Finish. This will create the entity class that we can call upon from a controller class. So naturally, let's create the controller class next. To do so, right-click on the JSF package and select New JSF Manage Bean, and then name the new class Prime Automobile Controller. Change the scope to Request, and click on Finish to create the class. Add a private field to the newly generated controller, and provide the type of List Prime Automobile. Name the list Automobiles. We then need to load this list when the view with the carousel component is accessed. Once again, let's make use of the JSF View Action tag to invoke a back-end action method that will be used to populate the list. So let's create the action method first, and then we will deal with the front end and the View Action tag. First, inject the Prime Automobile Facade EJB into the controller. Next, create a public method with no return type and name the method Load Automobiles. In the body of the method, call upon the EJB FindAll method to return all Prime Automobile entities and store them into the automobiles list. Lastly, be sure to generate getters and setters for the automobiles list. Let's open the index view and add the new PrimeFaces carousel component near the top of the view. Add a header to the carousel by specifying the header text attribute and set it equal to Prime Deals. The carousel component has a number of useful attributes for animating and customizing the transitioning of data elements. Since the carousel is meant to be used for showcasing data, it contains attributes such as circular, which enable continuous scrolling, and easing to set the animation effect. I highly recommend taking a look at the documentation on this component so that you can completely understand all of the available effects. We'll make a fairly basic carousel by specifying the numVisible attribute to indicate how many records to show, and set it equal to 2. Set the value attribute equal to the data source, which is the automobiles list within the Prime Automobile controller. Much like the data table, we need to specify the var attribute along with the name that we wish to use to refer to each entity record. In this case, we should specify auto. Next, let's add a graphic image to the top of the record, nested within the carousel. And for the purposes of this course, we'll simply add the same car photo that was used elsewhere in the application. After adding the image, add a panel grid inside of the carousel, and give it 2 columns. We will use these 2 columns to display labels and values for each field in the Prime Automobile entity. Therefore, add an output label for each of the fields, along with the corresponding output text component to display the value. Perform this same task for the make, model, and year. Close the panel grid and add another output label for the description, followed by a line break. Next, we will add an input text area component with 30 columns and 2 rows for displaying the description. We'll set this component to read only. Lastly, add a view action within the F metadata to the top of the view and specify the Prime Automobile Controller .load automobiles method as the action. Now, we can save the view and load it within the browser. Note how the carousel displays 2 records at a time, this being due to the num visible attribute which we set. Also, you can play around with the attributes to change the scrolling animation and other features if you wish to customize the component further. That does it for the carousel component. Much like the data table, this component can be used for displaying the elements of a list. However, we have seen that this component does a nice job of visually displaying the data. In the next video, we'll learn how to work with a pick list. Welcome to video 3.6 of the Mastering PrimeFaces video series. In this video, we will work with the PrimeFaces pick list component. The pick list component enables users to view a list of selections and select one or more results from that list to perform some action against. If we look at the PrimeFaces showcase, we can see that there are basic pick lists, which allow selection, and there are advanced pick lists, which allow sorting within the lists, as well as selection. In this video, we'll generate a pick list of the field names for the Prime Automobile entity fields. The pick list can then be used by a visitor to select which automobile criteria they wish to view. First, let's generate the data model that we will display within the pick list. As mentioned in the introduction, the pick list is going to display the list of fields available within the Prime Automobile entity. We will manually create that list within the Prime Automobile Controller class. The data type that must be used for the pick list is a dual list model. Let's go ahead and define the private dual list model field within the Prime Automobile Controller class and name it Automobile Field List. Assign a generic parameter type of string to this field to indicate that this dual list model will be composed of string values. Next, let's create a public method named Populate Automobile Field List, and in the method, we will generate a list of strings, and we will name it Automobile Field Source. We will then declare a second list of strings and name it Automobile Fields Target. We need to populate the source list within the field names now, and then we will generate the dual list model by passing both the source and target lists. To populate the source list, manually add each of the string-based field names in the Prime Automobile entity class. In a production application, we'd likely use another means of populating the list of fields, perhaps even a separate database table to hold the field names. Lastly, generate the accessor methods for the automobile list. Next, let's open up the automobile view and add a pick list component within the information tab. When adding the pick list, take a moment to look at all of the available attributes for customizing this component. The pick list is highly customizable, making it possible to add different effects, filters, and even transfer event handlers. In this video, we will only cover the basic pick list functionality. I highly recommend reading more within the documentation to further customize your pick lists. For our purposes, let's simply supply an ID of automobile fields as a value of Prime Automobile Controller .automobile list so that it is set to the data source. We also need to add a var attribute, and let's name this field as it will be the handle that we use to reference the individual list elements. Specify field for the item label as well as the item value attributes. Since we're using the dual list model containing strings, we simply set the label and value equal to the field. However, if we're using dual list model that consisted of objects, we may wish to set the label and value equal to the individual object fields, such ID and model. Lastly, to populate the data, we must add a view action to the top of this view and call upon the populate automobile field list method. Now, it's time to load the view. Type the application URL into the browser, and let's load the automobile.xhtml view. Note that the pick list contains strings for each of the fields within the prime automobile entity, just as we had coded. The fields can be moved from the source list to the target list. Now, let's customize the pick list just a bit and add the show source filter equals true attribute to the tag. Reload the view to find that we can now filter the data in the source list. We can also add a similar filter to the target list if we wish. This concludes the video on the pick list component. In this video, we showed how to create a pick list, including the back-end dual list model and the front-end UI code. Even though we did not perform any action against the data that was chosen in the pick list, we will add that functionality at a later point. It's easy to do. Simply call upon the data in the target list of the dual list model. In the next video, we'll take a quick tour of exporting data from a data table. We will then hook this pick list up to the data table in this effort to only show the columns that we wish to see. Welcome to video 3.7 of the Mastering PrimeFaces video series. This video will deal with the exporting of data from a data table into a spreadsheet or other format, such as a PDF. This can be useful when someone wishes to work with data rather than just view it in a web application. Once we have demonstrated how to use the exporter component, we'll take a look at how we can use the pick list component to select which data to display within an export. To get started, we're going to add a data table to the automobile view directly under our pick list component that we created in the previous video. This table is going to contain all the records within the prime automobile entity, so we want to make use of the automobiles list that we have created within the prime automobile controller class to populate that table. Therefore, what we should do is invoke another view action on the automobile view to call against the load automobiles method, which will then populate the list. So first, add a view action directly beneath the first view action we had created and call upon the prime automobile controller.load automobiles method. Next, add a data table component directly under the pick list. Let's make this a very basic data table supplying an ID of automobiles, a value equal to the automobiles list data source, and a var equal to auto. Then go ahead and add 4 columns to the table, one for each field of the pertinent data within the prime automobile entity. Once those fields have been added, go ahead and save the changes. Take a look at the output. You should see the pick list above the populated table containing the automobile data. Next, if we wish to include the Excel or PDF export, we need to add the Apache POI and iText libraries to our application. To do this, right-click on the Dependencies folder in our NetBeans project and select the Add Dependency option. Type POI into the Query field of the NetBeans Dependency Wizard, and then search for the appropriate dependency to add. Do the same for iText. Once you have both dependencies added, rebuild your project. Now, let's go back to our editor and add the data exporter component to our table. What we want to do is apply a nice visual icon to indicate each of the different possible export formats. You can find these icons on the PrimeFaces website on the data exporter form. Go ahead and right-click to save these icons to your machine. Once you've done that, add these icons to a folder named Icons within the Resources folder of your Prime Auto Sales application. Make sure that you save them in the .png format. Next, let's use those icons to show our user which formats the data can be exported into. Apply a facet to the automobiles data table after the last column and specify a name of footer. This will add the icon links into the footer of the data table to make it look nice. To implement the data exporter component, you need to embed it inside of a command link or a command button. In this case, we'll add an individual command link for each format that we wish to export: XLS, PDF, XML, and CSV. The embedded icon image along with the data exporter component inside of each. Let's walk through the first link, which will be exporting into the XLS format. Add a command link component with no attributes inside of the footer facet. Next, add a graphic image as a child of the command link and specify the library attribute of the graphic image and set it to icons, since we placed all of our icons into the icons folder. Next, specify the name attribute as excel.png. Add a data exporter component after the graphic image and specify a type of XLS. Set the target attribute equal to the ID of the data table that we wish to export, in this case, automobiles. And lastly, specify a file name attribute equal to automobiles. Go ahead and repeat this procedure for 3 more times, once for the type PDF, once for CSV, and lastly for XML. Be sure to specify the correct icon name. Now save the view and refresh your browser to see the changes. If you click on one of the icons, you'll receive the default operating system download and save routine. If we click on the XLS link, we will get an Excel spreadsheet containing the data from the automobiles table. That's it. Now, let's combine the power of the pick list with the exporter. First, we need a way to hide or show each column in the data table. We can use the rendered attribute for this, which accepts a Boolean value and is true by default. Let's go to the Prime Automobile Controller class and define 4 private Boolean fields, one for each column of the data table. Let's name them render make, render model, render year, and render description. Next, create the accessor methods for these fields. Now we need a way to submit the pick list selections once we are ready to display the export table. We will add a command button after the pick list in the view to submit the values, and we'll bind it to a method in the controller class, which we will set the Boolean values accordingly, depending upon which columns are chosen. Let's create that method as a public method returning void and name it apply selections. Implement the method by calling upon the automobile list dual list model to obtain the target list. Save the target list to a locally scoped field. Next, call upon the list contains method to see if it contains strings matching any of the entity class field names. If it matches the string, then set the field's corresponding render Boolean to false. Otherwise, set it to true. That should do it. Now, go back to the automobile view and add the P command button after the pick list. Specify the action attribute and bind it to the submitted selections method. Set the update attribute to the ID of the table. Let's give the button the text of submit. Lastly, we need to specify the render attribute for each of the columns in the table. Bind those attributes to their respective render XX fields in the controller. Now, save your changes and reload the application view. You can see that when you select a field in the pick list and hit submit, it disappears from the table. If you click on one of the export options, the corresponding file type will be generated containing the selected column data. That concludes the video on implementing a data export solution. We learned how to easily export data table into various formats using the data exporter, and we've also seen how to wire the columns of a table up to a pick list in order to filter our export data a bit. That concludes section 3 of the Mastering PrimeFaces course. In this section, we focused on data, and we learned how to make use of data table editing various ways and applying some advanced features. We also looked at the carousel component for displaying records of data in a visual manner, the pick list, and data exporter components. In the next section, we'll delve deeper into some of the various PrimeFaces input components and show some of their features. Welcome to the fourth section of the Mastering PrimeFaces video course. In this section, we'll be looking at some of the most widely required input components that PrimeFaces has to offer. In video 4.1, we'll learn about a few of the text components that can be used for developing sophisticated user input forms. Specifically, we'll take a look at the input text area, and input mask components. First, we'll provide a brief overview of the text components. Then we'll dive into how they can be used in your applications and in some of their options. Let's get started. The first text component that we'll cover is the input text component. This is the basic text component that is used widely for capturing free text within user input forms. In fact, you'll recall that we already know how to use this component as we've been using it when creating our input forms. What makes the P input text component different from the standard JSF input text component? Well, the most significant difference is that it allows one to apply the PrimeFaces skinning abilities to it. During the course of this video, when I reference skinning, I'm referring to applying different styles so that the components take on a different look and feel. The input text component is an extension of the standard component, adding the skinning abilities. The styles are automatically updated and enhanced for us to provide a cohesive theme for all of our components. If we visit the PrimeFaces showcase and take a look at the input text component, you can easily see the skinning abilities when we apply different themes to the page. To provide a quick example of using the input text component, let's open up the autoquote.xhtml view within NetBeans IDE and apply some of the attributes to the input text components that we've added to the view. In this view, there are currently two input text components, each without any attributes other than ID and value. The value attribute is not yet bound to a backend object. At this time, let's create the prime autoquote database table if we have not yet done so by executing the SQL within the create database SQL script. We will then generate the entity class as we've done in previous sections. If you need a refresher on how to do this, please refer to video 2.2. I've already performed these steps in this section so that we can save some time, but I'll show you how to do this in entirety in video 2.2. Next, generate the session bean from the entity class. Lastly, generate a new JSF managed bean controller and name it Prime Auto Quote Controller. Let's inject the EJB into the controller and then create a Prime Auto Quote field named Current. Let's go ahead and encapsulate that field to create a getter and setter. Now adjust the getter to first check to see if current is null. If current is null, then generate a new instance of current, otherwise return the current instance. Now we've got our infrastructure for the form. Let's bind the first input text component to the prime autoquote object. If we examine the attributes while working with the tags, we'll see that they are the same validation attributes as the standard component offers, namely max length and required. These can be used to specify the maximum length of text and also to designate the field as required, just like the standard input text component. If either component fails validation, then the field will be outlined in red once submitted. The only difference as far as usage is concerned is that if we wish to submit the field via Ajax, we should embed a P-Ajax tag rather than the standard F-Ajax tag. We'll get more into the working with the Ajax tags in Section 8, where we cover Ajax in detail. Let's move on to the input text area. The input text area component allows us to enter lots of text into a single component. The input text area component is an extension of the standard input text area component, and again, it is skinnable. It also contains a number of extensions to the standard component, making it much more flexible by providing more options for advanced usage. The input text area component contains an autocomplete attribute for providing autocomplete functionality, much like that of the standard autocomplete component. It also contains an auto resize attribute to make the component automatically resize when lots of text is typed. This can be beneficial to set so that the user can actually see everything they've typed into a field without scrolling up and down within the bounds of the component. the remaining characters counter will display the number of characters that are left for use. Let's start by adding a new field to the auto quote view and label it quote details. Let's add the input text area component after that label and provide an ID attribute of quote description. Next, add the cols attribute and provide a number of 20, which represents 20 character columns. Provide a rows attribute of 5, which represents 5 rows of data. We now need to set the value equal to PrimeAutoQuoteController.current.text field. For the purpose of this demonstration, let's go ahead and add the auto resize attribute and provide a value of true. Now, run the application again and load the view. There you go, so far so good. Let's move on. Next, let's take a look at the input mask component, which allows the developer to force a user to enter the expected text format into a field by specifying a mask over the input. For instance, if one wishes to have the user enter a social security number or a telephone number, the input mask component can be used to force the entry into a specified masked format. We took a brief look at this component in section 2 if you'll recall. In our example, we have the input mask component in use for templating a telephone number. Looking at the component more closely, you can see that the mask attribute is used to specify the desired input format. In the mask, a 9 can be used to represent a digit, star is used to represent alphanumeric, A is used to represent upper or lowercase letters. Let's take a look at this component in action. If we run the application now and try to enter some text into this component, we are forced to adhere to the mask that we've specified for the field. Looks like it worked just as planned. This is great news. That ends the video covering input text features of PrimeFaces. Now you have a bit of information under your belt to help you construct some user-friendly interfaces. In the next video, we'll cover one of those most significant input text components in my opinion, the autocomplete component. In this video, we'll take a look at a very powerful component, the autocomplete component. This component has the ability to return possible text results to a user via a selectable drop-down list as they are typing the text. This not only makes it easier for the user to type, but they can simply select the word that they're looking for in the drop-down list, and it also helps to resolve spelling issues that improve data integrity overall. In this section, we'll look at how to develop a search filter for an autocomplete component, how to work with the tag itself, and then we'll learn some advanced features. The autocomplete tag is one of the game changers when it comes to using PrimeFaces or the standard components. The autocomplete tag provides a convenient way for a user to begin typing and have their text completed for them, shortening the possible string options as the typing continues. The autocomplete component looks like a standard input text component, but it contains an additional attribute named complete method, which can be bound to a managed bean controller method for returning the possible autocompletion result strings. The method accepts a string as an argument, which is the text that is being typed into the field. It then returns a list of possible matches. Let's take a look at how it works by adding the autocomplete component to the autoquote form. What we are wanting to do is provide an autocompletion for the make and model automobile fields, based upon what the automobiles reside in the Prime Auto Sales database. To begin, let's open the autoquote view within the IDE and let's add a label for the make field. Next, let's add a corresponding input field, and we'll use an autocomplete for this solution. Let's provide an ID attribute and set it equal to make. Let's leave the complete method attribute blank for now, and let's add the value attribute and set it equal to PrimeAutoQuoteController.current.make. That's it for the front end until we implement the complete method. So let's go to the Prime Auto Quote Controller class and get started. Now that we're in the Prime Auto Quote Controller class, we will add a public method that returns a list, and we'll name it autocomplete make. And we will have this method accept a string for an argument, and let's name the parameter text. Now, inside of this method, what we want to do is pass the current text to a method which can be used to match up against the make field of the Prime Automobile entity and return all of the make fields that contain the same characters as those being typed. So what we need to do is create a method within the Prime AutoQuote Facade session bean, which will query the entity for all like fields. Let's open the Prime AutoQuote Facade bean now and add that method. Make the method public and make it return a list. And we will name it the same as the controller class method and also accept the same string argument. Now, within the method, we want to alter the string of text coming in as an argument by adding a % to each side of the text to represent the wildcards on each side. So let's create a field within the method named queryString, and we'll do just that. It is important that all the text that we are matching against is the same case, since we are not going to be case sensitive in the match. Therefore, let's convert the text to uppercase. Next, let's create a field that is a list of strings and we'll call it matches. This list will contain all of the matches that will be returned to the calling method. Now, we create a query against the Prime Automobile entity to return all object strings that contain a make that contains the text that we've already entered. You can call upon the database upper method to convert the make field text to uppercase for the matching purposes. Set the parameter as the query string field and call upon the getResultList method to return the list of matching results. The results of the query are assigned to the matches list, which we will then return to the caller. Now let's go back to the Prime AutoQuote Controller class and finish the implementation of the autocomplete make method. Within the method, make a call to the session bean method and return the results of that call. Fix the imports and you're good to go. Now, we need to wire this method up to the view. To do this, simply add the Prime AutoQuote Controller .autocomplete make method to the autocomplete tag's complete method attribute. Now, let's run the application and see how it looks. Load up the AutoQuote view and start typing Acme into the make field. And you'll see that several Acme makes are returned. This is because there are multiple automobiles in the database that have that make, and we're seeing a result for each. To correct this, we should only return distinct result values. This is simple. By applying the database distinct function to the o.make field within the query. You can now see that when we reload the view and begin typing, only one Acme result is returned. If there are other makes, such as Acorn and Academy, that can begin with the letter A, they'll also be returned. We can actually specify min query length attribute of the autocomplete tag to specify the minimum number of characters that need to be typed before the complete method is invoked. This works nice if we do not want to query the database with the first few characters. If we go back to the PrimeFaces showcase and take a look at the autocomplete page, we can see that there are multiple examples using the autocomplete component. It is possible to set a delay so that the complete method is not invoked until after the user is finished typing. This is configured via the query delay attribute. It is also possible to force the user to choose from a selection in a drop-down list rather than accept free text by specifying the force selection attribute. There are many custom attributes, too many to cover in this short video course. I suggest that you take a look at the showcase and documentation for further details. Everyone's going to love the autocomplete component within your applications as it makes the form entry much easier. The autocomplete component is very important as it provides another option for allowing users to select from a specified list of values and also enables convenience for the user. In this section, we looked at coding the back end and also working with the autocomplete tag. In the next video, we will take a look at the calendar component. In this video, we'll take a look at another important component in the PrimeFaces component library, the calendar component. We'll provide a brief overview of the component, then we'll look at adding the component to our Prime Auto Sales application, and we'll see how to work with the data from the component on the back end. Let's get started. The calendar component provides an easy way for users to input date and time information. Rather than forcing the user to type text, the component provides them with a calendar so that they can visually select the date that they would like. It's also possible to include time, and the component provides a visual slider to enable selection of hours and minutes. The component is also very customizable, providing the ability to restrict to designated dates, show multiple months at the same time, and more. Let's get started with adding a calendar component to our Prime Auto Sales application. Let's add the calendar component to the Auto Quote view and bind it to the Prime Auto Quote Quote Date field. So let's open the Auto Quote view and we'll add a new output label specifying the For attribute with a value of quote date. Then supply a value of quote date for the label text. Next, add a P calendar component with an ID of quote date and bind the value to the current Prime Auto Quote entity. Now, let's load the application and test out the component. Note how you can click on the quote date field, the calendar pops up, enabling you to select a date. Now, let's hook up the submit button to the back end to ensure that we're able to submit the date and all the other fields as needed. Let's open the Prime Auto Quote Controller class and add a public method named SaveQuote. Let's call upon the EJB create method, passing the current object. Let's return null so that we can stay in the same view after submittal, but let's go ahead and display the success message. Add a Faces message with the text quote saved. Now go back to the view and bind the submit button to this action. Back in the auto quote view, bind the submit button to the new save quote method and add a P messages component to the top of the form. Let's specify an ID of messages for that component. Now, let's specify the update attribute of the P command button and set it equal to messages so that the message component is updated when the form is submitted. Go ahead and bind any remaining values in the quote form that have not yet been bound to the Prime Auto Quote entity. Add a generated sequence for the primary key ID field so that we can insert new records into the entity. Now, let's run the application again. And now we can see that the date is saved into the entity without an issue. The calendar component has plenty of advanced features to help customize the application. Go back to the auto quote view within the IDE and take a look at the drop-down list of attributes when you use the autocomplete. As you see, there are plenty of customizable options. For instance, the before show day attribute can be equal to a callback method for invocation before the day is displayed. In this case, let's go ahead and set the disabled weekends attribute to true since the Prime Auto Sales company does not work on quotes during the weekend. We can also specify a maximum hour, time, etc. We can specify the desired date pattern, the way the control pattern is displayed, and more. Please refer to the documentation for more information on these advanced features. That's all for the calendar component. There are far too many features to show in this brief section, and it's worth investigating further to see which options would work well in your application. In the next video, we will take a look at select components. In this video, we will take a look at the PrimeFaces select components. In particular, we'll go over the different components that PrimeFaces has to offer. We'll learn how to utilize the One menu and build a data model for populating the menu. PrimeFaces offers plenty of options for select components. Today, we will specifically look at the One menu, which is perhaps the most often used select component. The Select One list box allows the user to see multiple selection options at one time. The Select Many menu provides the option to see a portion of the select options on screen at once, and it also allows one to select multiple options rather than just one. The Select Many checkbox offers a different spin on the Select Many component, providing a checkbox overlay in a drop-down menu. Another great component is the Multi-Select List box, which provides a parent-child relationship for the selection criteria. Let's take a closer look at the One menu, which allows one to select an option from a drop-down menu. The One menu is populated from a list of select item objects, which contain the selection option and label. In the Prime Auto Sales application, we wish to add a Select One menu to contain the model names for automobiles that are in the store. Therefore, we need to query the data from the Prime Automobile entity to retrieve all the model names, and then add them to a list so that they can be bound to the One menu. Let's begin by opening the Prime Auto Quote Controller class and creating a public method that returns a list. We'll name the method Model List, and the method will not accept any arguments. Now, what we'd like to do is return all models of automobiles that are restricted by the make that the user has selected in the form previously. We will not build out the entire workflow here, but we will account for any make that has previously been selected by the user. Therefore, in this method implementation, we will want to call upon the session bean to query the prime automobile entity for any model names that match the selected model, if it is already populated. Otherwise, just return all the model names. To do this, we need to open up the prime auto quote facade session bean and create a new public method, which returns a list, and name it obtain automobile model. This method should accept the string, which will be the make which has been selected by the user on the form. Inside of the method, check to see that the make is null or if it's greater than 1. If so, then query the prime automobile entity for all model names that match the given make. If it is null, then return all model names. Now, go back to the controller class and call upon this method within our model list method. Let's assign the value of that call to a list models and pass the current make value. We are not able to simply return this list for use within the one menu because we need to pass a list of select items for use with that component. Therefore, we now need to iterate this list and create select item objects for each element in the list, adding those to another list which will be returned by this method. So let's create the return list and set it equal to array list. Next, iterate over the list of model names and create a new select item for each, adding the model name as both the label and ID in this case. Although in some cases, we'd use the primary key from a database table to populate the item ID. Resolve imports and return the new return list. Let's add the select one menu to the auto quote view. So first, add a label with the for attribute of model and the text of model for the label. Add a P select one menu with an ID of model and a value bound to the current prime auto quote record. Leave the tag open and embed an F select items tag within it. This is where we specify the data model for populating the list. Assign the value to the model list method that we had created. The last piece of the puzzle is to send the make selection to the controller via Ajax so that it can be picked up by the model list method when creating the model listing. Therefore, add a p-ajax tag within the p-autocomplete tag for the make and update the model component when the Ajax is submitted. Now, run the code and let's see how it looks. As we can see, when we run the application, the model is full of the automobile model names. We can select one of the options from the list. If we had more make options, then the list of results would change when we entered a different make. Components are easy to use, and they provide a great option for allowing users to choose from a list of selections within an application. That concludes video 4.4 of the Mastering PrimeFaces series. In this video, we took a brief look at the Select One menu component, how to use it, and how it works. In the next video, we'll take a brief look at checkboxes and radio buttons. In this video, we'll cover two important components, the checkbox and the radio button. In PrimeFaces, the checkbox component is named Select Boolean Checkbox, and the radio button component is named Select One Radio. The Select One checkbox component will render a checkbox on the view. It is the standard JSF checkbox with some additional theming. As such, we will add one to our Prime Auto Sales application and bind it to the controller class so that we can see the effect of checking and unchecking the box. To get started, let's add a Boolean field to the Prime Auto Quote Controller class, and let's name it Opt-in. This will designate whether the user would like to opt into a mailing list. Create the necessary getter and setter for the new field. Within the setter field, let's specify sysout to display the value of the opt-in field for test purposes. Now, switch over to the auto quote view and add a select one Boolean component to the view. Provide a label with the name of opt into mailing list and set the for attribute to opt-in. Next, create a select one checkbox component with an ID of opt-in and a value bound to the field that we just created within Prime Auto Quote Controller. Embed a p-ajax tag inside of the checkbox so that the changes are propagated to the controller class without submitting the form. Let's now test the form. Note that when you select a checkbox, the server log is displaying the current state of the opt-in field. The Select One radio component is used in much the same way as the Select One menu. It is simply an extended version of the standard Select One radio component with added theming. It accepts a list of values and select items that can be used to display the results. The component only allows one selection, just like the Select One menu. If you're not familiar with the Select One menu or you haven't yet watched video 4.4, please do so for a more in-depth look at the implementation. For the purposes of this demonstration, we'll simply change out the Select One menu component that we added to the AutoQuote view in video 4.4 with a Select One radio component so that you can see how similar they are. Open up the AutoQuote view and find the Select One menu that was added previously. Simply change the Select One menu out with a Select One radio component. The value attribute is bound to a string field in the Prime AutoQuote entity, and the Select Items tag is bound to a list of automobile models. Each of the models is contained within the Select item. Once you've swapped the tags, run the application and see how it works. Note that with this component, each of the options is displayed in a horizontal line. We can change that if desired by laying the options out in the table instead. That wraps up this brief section on the checkbox and radio button controls. They're easy to use and very similar to the other input components offered by PrimeFaces. This concludes section 4 of the PrimeFaces input components. In this section, we covered the input text components, autocomplete, calendar, select components, and the checkbox and radio controls. In the next section, we'll be diving into dialogues and messages. Welcome to the 5th section of the Mastering PrimeFaces video series. In this section, we'll take a look at the PrimeFaces dialogues and how we can use them to enhance the usability of our applications. We'll also delve into the PrimeFaces dialogue framework, which enables one to develop dialogues using Java code. Let's get started. In video 5.1, we will introduce the dialogue component, as well as create a dialogue that contains some simple text. We will then take a look at some of the advanced attributes that can be used with the dialogue component. The dialogue component itself is simple. It is a component that can contain just about any other component, including entire application views. The dialogue component is oftentimes used to display information such as helpful text pertaining to a particular application section, or perhaps some information that requires a yes/no decision from the user prior to proceeding. If you look at the PrimeFaces showcase, the dialogue is very basic. It can become modal, and it can also utilize an animation for when it appears on screen or when it is closed. In this section, we will create a simple dialogue and take a look at some of the attributes that can be applied to the dialogue. To get started, let's open up our IDE and let's go ahead and open the template.xhtml page of the Prime Auto Sales application. What we're going to do is create a simple dialogue that displays some basic text in this section. In the long run, we will change this dialogue so that it can be used to display a poll for obtaining information that can help our company learn more about our customers' buying requirements. Add a P dialog tag to the top of our template and add it directly under the body tag. It is important where we position our dialogues because if they reside within other elements on the page, then the identifier may change, as it would need to include the prefix of its parent element. Adding to the top level of the view is safe, so we can refer to it by the name only. The pdialog component itself is a container of sorts. Therefore, it will not display anything on its own. We will also need to add a button or a link to open and display the dialog. Let's add an ID of poll dialog to the dialog component, as well as a widget var of poll dialog. The widget var will be used to reference the dialog from our button or link. Inside of the opening and closing P dialog tags, let's simply put the text, "Here's our poll," for now. That's it for the dialog. Let's add the command button component and make its type button. Specify the onClick attribute and set it to PF poll dialog. Now let's take a short aside to look at that syntax that we just applied to our command button component. The PF indicates that we're binding into the PrimeFaces JavaScript framework. Here, we're calling upon our poll dialog, which is registered to the JavaScript framework via the widget var. set the value of the pull for our button, and now let's run the application. Note that when we push the button, the dialog displays in the middle of the screen, which is good. However, it's not very predominant. It almost blends into the site. This is because we can actually still interact with the other components on the page, even with the dialog displayed. We can change this behavior by specifying the modal attribute of the dialog. Go back to the view and specify the modal equals true attribute and try again. Now, when we rerun the application, you can see that when the dialog is invoked, nothing else can be touched until it is closed. It also stands out much better as the background is now shaded. Up to this point, we've worked with the minimal attributes on the component. Let's go to the IDE and invoke the autocomplete on the component so that we can see some of the other attributes that are available for use. There are many attributes, as you can see. We can make the dialog unclosable by specifying false for the closable attribute. We can also make the escape key close the dialog by specifying the close on escape attribute. The dynamic attribute specifies whether or not the body of the dialog should be loaded before it is displayed. Also, all the standard positioning and size attributes are available for use. For fun, let's add some nice show and hide effects to this simple dialog. The effects can be blind, bounce, clip, drop, explode, fade, fold, highlight, puff, pulsate, scale, shake, size, slide, and transfer. Try adding one or two of these effects to the show effect and hide effect attributes and run the application to see them. That ends the first video on the PrimeFaces dialog. To this point, we've not even looked at the Java code whatsoever when it comes to the dialog. We can do quite a bit with the dialog without even touching the back end. However, in the next section, we'll take a look at using the dialog framework to invoke and customize dialogs from within our Java code rather than in the views. Welcome to video 5.2 of the Mastering PrimeFaces video series. In this video, we'll delve into the dialog framework, which enables developers to programmatically produce dynamic dialogs that are derived from external JSF views. This can be beneficial when a particular business action requires the presentation of a dialog or when the dialog preferences need to be dynamically set to fit the situation. In this section, we'll take a look at the framework and how it can be used to dynamically create dialogs. We will then look at applying some of the custom attributes to the dialogs through the use of the framework. Let's get started. This dialog framework is quite simple. It allows for programmatic invocation of an external view into the dialog rather than embedding the pdialog component into a view. Let's take a quick look at the PrimeFaces showcase so that you can see a brief overview of the framework. As you can see, the dialogs that are created via the framework function in the same manner as the standard dialogs that have been created with the pdialog tag. If we look at the code, however, we can see that the button is invoking a backend method which instantiates the dialog. The PrimeFaces request context class has an open dialog and close dialog method. These are the methods that are used to open or close a dialog programmatically. Based upon using this framework, the dialogs are then created and destroyed at runtime. If we look at the PrimeFaces documentation, we can see that there are two versions of the open dialog method. The first accepts a single parameter, which is a string-based name of the XHTML file that contains the dialog content. A second accepts a map of options as well as a map of parameters to send to the dialog. This allows us to customize the dialog as needed. Going back to the PrimeFaces showcase, you can see that there are three types of dialogs that can be created using the dialog framework: basic, message, and data. The basic dialog is just the same as an ordinary dialog, whereas a message dialog is specific to displaying a message for user feedback. Lastly, the data dialog allows one to pass and retrieve data via the dialogs. In this section, we'll take a look at the standard dialog. Before we can use the dialog framework, we have to perform a bit of configuration within the faces config XML file. Let's open up the faces config XML of our Prime Auto Sales application and add the dialog action listener dialog navigation handler, and the dialog view handler. We can do this simply by copying these configurations from the documentation and pasting within the appropriate areas of the Faces config XML file. These classes must get registered to the application to allow the PrimeFaces dialog action framework, navigation, and view handling to be made available. The dialog action listener implements the Faces action listener and Faces listener and enables action handling within the dialogs. The dialog navigation handler extends the standard Faces configurable navigation handler for easy navigation between dialogs and application views, and the dialog view handler assists in embedding views within the dialogs. We can register these classes by simply copying these configurations from the documentation and pasting them within the appropriate areas in the Faces config.xml file. If our project does not yet contain a Faces config file, then right-click on the WebInf folder, select New, Java Server Faces, JSF Faces Configuration. Then retain all the defaults when using the wizard and click Finish. Now, paste the copied text from the documentation into this file. This is a good time to make use of NetBeans' formatting feature as well by right-clicking on the file and choosing Format. Let's consider the case where we would like to programmatically generate the poll dialog that we created in the previous section rather than embedding the P dialog component into the site template. To do so, let's first create the content of the poll dialog by creating a new folder in our web application to contain the dialog views. Name it Dialog. Next, create a new XHTML file and name it Poll. Go ahead and copy the contents of the about.xhtml view into the new view and delete all of the Facelets specific code. We do not want to apply a template to our poll dialog. Next, add a simple message to the form that says, "Here is our poll," and change the title of the view to Poll. Assuming that we already have configured our environment accordingly within the Faces config, we can now alter the action method that is bound to the command button within the information section of our site so that it invokes the newly created poll.xhtml dialog rather than the dialog which we embedded into the view. To that end, go to the template and find the command button. Let's take out the on-click action that we were using to invoke the original dialog, and we will add the action listener attribute. Let's assign the action listener attribute to an action that we will create within the main view controller class named invoke poll. Our invoke poll method can return void, and in it, we will simply obtain a current instance from the request context. Then we will invoke open dialog and pass the name of our dialog view. Be sure to fully qualify the path by appending the dialog folder name to the front. One note about the dialog framework is that it needs to make use of Ajax in order to function properly. So, if we assign this action method using the action attribute instead, it would not invoke the dialog as expected. Now, go ahead and save, run the application, and you can see that our dialog is now being invoked via the newly created poll.xhtml view using the framework. Note that we have lost the modal functionality of the dialog. We'd like to gain that functionality back, and we can do it by adding that property to a map and passing the map to the open dialog method. Let's go back to the invoke poll method, and we will create a map of string objects. Name the map options and add a name value pair to it by adding modal along with the value of true. Now, let's pass the options map to the open dialog method, and since we're not going to pass any parameters, just pass a null as the third parameter. Now save and run the code again. You can see that the dialog is now in modal fashion. In this video, we took a brief look at the dialog framework. We learned how to generate dialogs programmatically and how to add some options to them. You can also pass data between dialogs and display messages, which you can see in subsequent sections. In the next video, we'll take a look at creating input dialogs. Welcome to video 5.3 of the Mastering PrimeFaces video series. In this video, we will build upon the information that we looked at in the previous video with utilization of the dialog framework. In this video, we will change the pull dialog so that it contains a couple of input components, and we will wire those input components to a controller class method, which we will then do something with the contents of the form. For the purposes of this example, we will be creating an input poll that contains 3 questions. The questions will be bound to a poll object, which is simply a POJO for now. So first, we need to create an object which will represent the poll. We can do this by creating a new package in our application by right-clicking on the source packages within the IDE and selecting New Package. From there, name the package org.packed.primeautosales.object. Now, create a new Java class in that package and name it poll. Let's add 3 answer fields, which will be strings. Create a no-argument constructor. Now go ahead and generate the getters and setters for the private fields that we have declared. Next, create a new poll controller class by selecting New, JSF Manage Bean, and make the controller session scope. Let's create a private field of the poll object type, and we will name it Current. Create the getters and setters for this field now. Lastly, let's modify the getCurrent method by first checking to see if the current object is null. If it is null, then create a new poll object. Otherwise, return the existing poll object. Now, go to the poll.xhtml view and create a panel grid with 2 columns within the form. We're going to create a label and answer field for each of the 3 questions using the output label and select one radio buttons, respectively. Let's add the 3 labels first. So, create the first output text component for each and set each of the 3 questions. For the first question, ask, what type of car do you prefer? Second, ask, how long do you typically own a car? And third, do you like our site? Now that we have 3 labels in place, let's add the select one radio options for each. For the first radio, add 3 options, car, truck, and SUV. Set the select one radio value to the current poll object's answer 1 field. For the second set of answers, add the radio button and set the value equal to the current poll object's answer 2 field. The fields should be labeled 1 to 2 years, 2 to 4 years, and more than 4 years. The values should be 1-2, 2-4, and 4+, respectively. For the third set of answers, the radio buttons should simply be labeled and valued yes and no. Lastly, to complete the form, add a command button and set the action listener to the pollController.submitPoll method. Remember, we need to use Ajax for the dialog framework to function properly, so we are setting the action listener method here. Now, go to the poll controller class and create the implementation for the submit poll method. Let's go ahead and move the invoke poll class from the main controller class into the poll controller and clean things up just a bit. Next, let's change the reference to the invoke poll method in the template.xhtml. Now it's time to implement the submit poll method. For the purposes of this demo, let's not submit the poll results to any collection just yet. Instead, in the submit poll method, let's go ahead and call upon the requestContext.getCurrentInstance.closeDialog method, and let's pass the current poll with it. Next, let's set the current poll to null and initialize things. Passing the poll to the closeDialog method effectively passes the data back to the calling view. However, in order to make this work correctly, we need to trigger the dialog return event within a p-ajax child of the dialog invoking button. This event will handle the data when it returns to the caller. Now that we've implemented the submit poll, go back to the template.xhtml and add a p-ajax tag inside of the poll command button. Set the event attribute to dialog return and set the listener to pollController.handleReturn. Of course, now we need to implement the handle return method in the poll controller. Let's go back to the poll controller and we will create a public method returning void and accepting select event. Inside of the implementation, call upon the event.getObject method cast it to a poll object. Now, for grins, let's simply print out the answers to our poll questions to the server log, just so we can see that the data is being returned. Run the poll and select some answers from the questions. When you hit the button, the poll will close and the answers will be displayed to the server output. In this video, we dove into creating input forms within dialogues. We also used the dialog framework to pass data from input dialog back to the caller. In the next video, we'll take a look at creating a data selection dialog, which will display a data table which allows selections. Welcome to video 5.4 of the Mastering PrimeFaces series. In this video, we will look at invoking a dialog from selecting a table row. Once a row is selected, then the selected row data will be displayed in a more detailed dialog. Let's get started. In this video, we'll modify the current users list of the Prime Auto Sales application such that when a row is selected, a dialog will be displayed with more detail on the selected user. To get started, open up the current users.xhtml view and add a trailing column. For the column header, use the word detail. Inside of the column, we will have a command button which will contain an embedded fSetActionListener tag to set the selected user as the current user entity within the user registration controller class. Now, add an onComplete attribute to the command button and use the PrimeFaces JavaScript framework to invoke a dialog named userDialog. All of this loads the selected user so that we can display more details within the dialog, which will be embedded in this view. Lastly, we'll need to add the update attribute and specify the user detail for update. Let's now add a basic pDialog tag after the data table within the current user's view and provide a widget bar of userDialog. Make the dialog modal. Inside of the dialog, add a panel grid with an ID of user detail and 2 columns. This panel grid will contain labels and values to display user detail. Let's add a couple for displaying the user's first and last names for the sake of brevity. Let's also add a label and a pSpinner component for the age so that we can modify the user's age if needed. For the pSpinner, set an ID of age and set the value to userRegistrationController.current.age. Close the panel grid and add a command button with an ID of save, a value of save, and action listener of userRegistrationController.saveUser. And let's specify an update attribute so that we can update the current user table and the growl message components, registered user list, and current users form messages. Now, let's open the user registration controller class and add the method for saving the user. The method should be named saveUser, and it should not return any value, but it should accept an action event as an argument. In the implementation, let's create an instance of PrimeFaces requestContext object, which we'll discuss in more detail later on, and check to ensure that the age is greater than or equal to 18. If so, create a new faces message to indicate a successful update, and set a new callback parameter named age with a value of true. This callback parameter will be utilized on the client to determine whether the server-side action was a success. If the age is not over 18, then set an error message, and specify the same callback parameter with a value of false. That's about it. But how do we close the dialog? Well, let's utilize the callback parameter to determine whether the save was successful or not. If so, then we will close the dialog, and if not, then the dialog will remain open. In the command button within the dialog, specify the onComplete attribute and set it equal to valid age, passing XHR, status, and args, which is a client-side JavaScript function that we will now implement. In the current users.xhtml view, just below the UIDefine tag, create a script, and within it, create a function named validAge that accepts XHR, status, and args as arguments. The implementation is simple. First, let's check to ensure that there are arguments using an if statement. If so, then check to see if args.age is set to true. This corresponds to the callback parameter that we set up in the business method. If it is true, then let's close the dialog using a call to pf passing user dialog string .hide. Now that we have added the dialog and bound it to the table, we can run the code and check it out. Note how we do not need to add any back-end code for this solution. Everything's wired to the view. We can now update the user's age via the dialog, and validation will determine whether the dialog will remain open or if it will close upon saving. We learned how to easily build a dialog to display more information on a selected row within a data table. In the next video, we'll learn how to build an interactive dialog which requires a user response to proceed. Welcome to video 5.5 of the Mastering PrimeFaces video series. In this video, we'll go over the basics of adding a dialog that requires user intervention in order to proceed. The event can then be used to trigger logic in the controller class. Let's get started. Sometimes it is useful to include interactive dialogs within portions of your application. Such dialogs require user intervention in order to proceed. We've all been to websites or used applications that pop up a message asking if we'd like to proceed. This is the type of dialog that is possible to create using the PrimeFaces confirm dialog. The confirm dialog solution is comprised of a couple of different pieces. The trigger must be a command button or link with an embedded pconfirm tag, which displays the confirmation message. The command button or command link will invoke a backend action method via action listener attribute, which then performs some logic depending upon the selection that is made. The confirmed dialog component must then reside within the same form, and it can contain customizable attributes such as modal and so forth. The confirmed dialog component typically contains two command buttons, one with the value of yes and the other with the value of no. When the yes button is clicked, the action listener method of the trigger is invoked. And when the no button is clicked, the dialog goes away without further action. This technique describes the global configuration, which is useful for implementing more than one confirmation dialog. The other way to implement is a single confirm dialog or non-global, which uses JavaScript to show and hide functions. In this video, we will cover the global implementation. Let's add a confirm dialog to the Prime Auto Sales application to get some practice. We'll add a button titled Clearance to the information pane of our application. When the user clicks it, they'll be asked if they're in good enough health conditions to withstand the shockingly low prices that follow. If they proceed, then the clearance view, which we will create, will be displayed, otherwise not. Open up the template.xhtml and add a command button under the Pull button. Set the value of the button to clearance and set the action listener attribute mainViewController.navigate to clearance method. We will then create that method in a moment. Inside of the command button, let's nest a pconfirm tag and set the header attribute to confirmation. The message to "Are you in good enough health condition to withstand these shocking deals?" and set the icon to UI icon check, which is a PrimeFaces standard icon. We also should specify some special style class attributes for these buttons per the PrimeFaces framework. So set the style class equals UI-confirm dialog-yes and UI-confirm dialog-no. Now go to the main view controller and implement the navigate to clearance method. Make the method open up a clearance dialog by implementing the PrimeFaces request context and opening the dialog names dialog/clearance for now, and make a copy of the dialog/pull.xhtml file and name it clearance.xhtml. Now go ahead and run the code, and you can see the component in action. That wraps up video 5.5 of the Mastering PrimeFaces video series and concludes section 5 altogether. In this section, we covered all kinds of dialogues, and in the next section, we'll take a look at dashboards and charts. Welcome to the 6th section of the Mastering PrimeFaces video series entitled Developing Graphs and Charts. In this section, we'll be taking a look at various charting components that come packaged with PrimeFaces. These components provide enough features to create a fully capable dashboard for displaying data in a graphical manner, making it interactive where needed. All PrimeFaces charts are displayed using the P-chart component, using different data models and attributes to display data in different ways. In this section, we'll take a look at area charts in particular. Looking at the PrimeFaces showcase, you can see that area charts are beneficial for comparing data. Let's start by seeing how we can add an area chart to the Prime Auto Sales application to show sales comparisons for different makes and models of cars. I'll mention ahead of time that all the data will be hard-coded for the purposes of moving things along in this course, but you can always substitute the dynamic data from a database or calculation in your own custom apps. Let's get started. To create an area chart, a line chart model must be developed. The line chart model contains a line chart series for each area that will be plotted on the chart. A line chart series is a set of data. The line chart model then accepts metadata regarding the chart, such as the title, legend, position, axis data, and so forth. In the Prime Auto Sales application, let's create a new managed bean controller named Sales Chart Controller, and let's make it session scoped. Now, add a private field of type line chart model to the controller class and name it Sales Chart Model. Resolve the imports now. Let's add a method that will get invoked after the controller is constructed. We will name it init, and it will not return anything, but will invoke a method named createSalesModel, which we will create next. Annotate the init method with postConstruct so that it is invoked after class construction. Next, create a public method that returns a line chart model object and name it getSalesChartModel. This will simply be a getter method to return the line chart model for use in the view. The next step is to create a method that is named createSalesModel, which returns nothing, but the implementation will be the setup for the sales chart model. First, instantiate a new line chart model and assign it to Sales Chart Model. Next, create the first series of data, which will be named Sedan Series. We can do this by instantiating a new line chart series and assigning it to Sedan Series. We want to color in that area, so set the fill on Sedan Series to true and set the label to sedans. Next, let's add a few sedan names along with numbers to match sales. Now that we've added sedans to the area chart, let's add a truck series. So for the truck series, we do the same as we had with the sedans, and we'll copy the data from a predefined set to speed things up just a bit. Now let's set up the axis data. To create the axis for comparison, first create an axis field named X and assign a new category axis with the title of cars. Configure accordingly by setting the x-axis to Sales Chart Model. To do this, we call getAxis on the Sales Chart Model, then call put and pass the axis type.x as well as the new axis field we created. Next, we create another axis named y, and we grab that data from the model itself by invoking the model's getAxis method and passing the axis type.y. Set the y-axis label of sales and a min value of 0 and a max of 50,000. Again, the data is hard-coded here for brevity, but we could read this data from a data source to dynamically create the model in a production scenario. Now that we've created the model, the next thing to do is assign to the P-chart component, which we will place into a new view in the admin folder. Let's create this view by right-clicking the admin folder and selecting New, XHTML, and naming it Sales Dash. To make things easier, copy everything from the other admin view and paste it into salesdash.xhtml, overwriting the default code. Now go back and remove the contents of the UI-defined section, as we'll replace them with the new dashboard components. First, add a form and provide an ID of Sales Dash. Next, let's add a PrimeFaces panel component, providing a header of Sales Charts. Within the new panel, add a P-chart component, specifying the type attribute as line, the model attribute as SalesChartController.SalesChartModel, and we'll set the height up to 250 px for now. Save the new view and then run the application. Manually load the new view URL into your browser. When the area chart loads, you can see that it performs a good comparison of our data. Also note that if you click on one of the area chart models, sedan or truck, it will become hidden on the chart. So this can be useful if you have many different data models on a particular chart. Let's take a moment and signify the importance of the series data in our chart. If you go back to the Sales Chart Controller and navigate to the Create Sales Chart Model method, comment out the lines where we add the truck series to the chart model. Save our progress, and then run the application again. As you can see, when you visit the chart, there is no longer any truck data appearing. If we do not add this series to our chart, the data does not exist. Go ahead and uncomment the line and rerun the code once again. And we can see that the world is all good once again, and everything is back in order. That does it for the area chart. As you can see, the PrimeFaces chart component and associated data model makes it easy to construct an area chart for performing visual comparisons. Although we created rather basic charts in this section, you should keep in mind that there are a number of attributes that can be set on the charts. For instance, one can set a tooltip, specify shadow, or even specify a zoom feature that could be handy for better comparisons with zooming in on the portions of the chart. I recommend that you play around with the attributes while setting up your models so that you have a chance to see everything that is possible. In the next video, we'll touch upon the bar chart. Welcome to video 6.2 of the Mastering PrimeFaces video series. In the previous video, we introduced the PrimeFaces chart component, which allows one to place various different charts within a view. In this video, we'll take a look at another type of chart that could be displayed with the component, the bar chart. In particular, we'll delve into some details regarding the bar chart model, and we'll cover how to use it within a P-chart component. As you'll see as we go through some of the subsections of section 6, the main differentiator between each of the different charts is the data model. In the case of the bar chart, what we want to use is the bar chart model to display our data. Our bar chart is useful for providing visual data over a specified interval. If we briefly look at the bar chart in the showcase, we can see that it does a good job of providing a good comparison with only a quick glance. The documentation within the PrimeFaces showcase can help us understand how to build a bar chart model. As you can see from the code example, the setup for the bar chart model is very similar to that of the line chart model, which we demoed in the previous video. As you can see, there is a standard bar chart model and a horizontal bar chart model. For this video, we want to add a bar chart model to the sales chart dashboard that we started in the previous video. We'll be creating a standard bar chart model to show different sales trends for the company from year to year. To get started, let's open up the sales chart model that we created in the previous video and create a private field of type bar chart model and name it sales trend model. Create accessor methods for the newly created field. Now create a new public method returning void. Name this method create sales trend model. We will be constructing the model using this method. Inside of the method, we will create one or more chart series objects, each of which contain a series of related data. The chart series objects are then added to an instance of the bar chart model, and finally, the model metadata such as title and axis information should be set. In this case, we will create 3 chart series objects, one with sales data for sedans, another with data for trucks, and the last one with data for SUVs. To speed things up, let's copy and paste the chart series creation code from some data that I set up previously. By the way, don't pay too close of attention to the sales data, I just made it up. In real life, we would likely be reading this data from a data source and then setting up the model. Once we have the chart series set up, create an instance of the bar chart model and assign it to our class member identified as sales trend model. Next, add each of the chart series objects to the model. Set the title of the model to sales trends and set the legend position to NE. Lastly, we need to set up the axis. So to do that, we need to get each of the axes from the model by calling salestrendmodel.getAxis, and then specifying the axis we wish to obtain. First, we'll grab the x-axis, and we will set the label to auto type. Next, grab the y-axis and set the label to sales. We will then configure a minimum and a maximum for the scale. Let's just say 0 to 3 million. Oftentimes your customers will want a specific color on the charts. Maybe a company had an official color that they'd like to be shown on the chart rather than something randomly chosen by the application. We can specify colors by setting the Set Series Colors attribute on the model and then entering a string value for each of the colors that correspond to the series in the model. This string should be a comma-separated list of the hex color codes for each series. In this model, let's say that the colors for the company are blue, white, and red. We can specify these colors using the notation set series colors, passing the hex codes for the selected colors. Go ahead and add the colors to the model so that we can see the company colors in action. That does it for the model. Now we need to load the model when the controller is created. So we will add a method, create sales trend model, to the init method, which is annotated with the post construct. The next piece of the puzzle is adding the p-chart component to the view. We will want to add it to the same view that we worked in the previous video. So let's open up the admin/sales-.xhtml view. We want to add another panel that will contain a trend chart. So let's just copy the panel that we use for sales charts and we will paste directly underneath. We will change the name to Sales Trends, change the p-chart ID of the newly copied section to Sales Trend Chart, and set the line attribute to bar. Set the model to Sales Trend Model, and let's leave the style attribute as is. Now, let's run the application and see how it looks. Once the application has been built and is running, visit the Sales Dash view. Note that each of the different auto types is a different color on the chart. When you hover over a particular bar, you'll see the exact detail behind it. Lastly, when you click an auto type in the chart legend, it hides that type from the chart. That does it for the bar chart using PrimeFaces. As you can see, the model is very similar across the different chart types, and the p-chart component can be used for each. In the next video, we'll cover the ever-popular pie chart. Welcome to video 6.3 of the Mastering PrimeFaces video series. In section 6, we've been covering the charting components of PrimeFaces. In the previous two videos, we looked at the area chart and the bar chart. In this section, we'll cover the pie chart. If you look at the PrimeFaces showcase, you can see that the pie chart provides a good visual for looking at percentages. Take a look at the documentation, and you will see that the pie chart construction is a bit different from the previous charts. We do not have to populate and create chart series objects for constructing a pie chart. Instead, we work with the chart model object itself. Without further ado, let's get started with the pie chart. In our example, we'd like to create a pie chart that will show us the different percentages of data for Prime Auto Sales sales trends. Specifically, we'll show what auto types are selling the most in a visual representation using the pie chart. Let's use the same sales chart controller class to construct our pie chart model. So go ahead and open the class in NetBeans IDE and create a private field named Sales PCT Model of type pie chart model. Next, encapsulate the field to create a getter and a setter so that we can access it from the view. Next, create a public method returning void and name it Create Sales PCT Model. This will be the method where we implement the pie chart model for our application. Within the method, instantiate a new pie chart model and assign it to the Sales PCT Model field. Next, add a title for the model by setting the title attribute to Auto Type Sales Percent. We have the option to specify where we would like the legend to be placed, and I like it when the legend's on the right or east side. Specify the legend position by setting the legend position attribute to E. We want the pie chart to contain a fill, so we will not specify the fill attribute as is true by default. We would like to show data labels, so set the Show Data Labels attribute and provide a value of true. We can also set the size of the pie chart by setting the diameter attribute. Let's specify 200 for this attribute. You can really just play around with this attribute to get the size of the chart that you'd like for your application. Now the pie chart model metadata is set. So let's add some actual data to the chart by simply calling set on the model and passing a series of string value pairs. We will pass a pair for each of the three auto types. Set the auto type of sedan to 375 to represent that we sold 375 year to date. Set trucks to, let's say, 284, and set SUV to 215. Lastly, let's invoke this method within the init when the class is instantiated. Now we're ready to add a pchart component to the view and assign a model to it. Open the admin/sales-.xhtml view, and we want to add another panel to display the pie chart. Underneath the panel for the bar chart, let's add a new panel and specify the header of sales %. Next, add a pchart component within and specify an ID of sales PCT and set the type to pie. Set the model to sales chart controller, sales PCT model, and specify a width of 500 px and a height of 400 px. Now we're ready to save, build, and run the application again to see how it looks. Once the application is loaded, open the sales-.xhtml view in the browser. As you can see from the chart, we have clearly sold more sedans than any other type of auto this past year. If you hover over one of the chart sections, you can see that it reacts by changing shades. The legend in this case is not interactive, as we cannot hide different types in a pie chart. This wraps it up for the pie chart. As you can see, the pie chart is a bit more simplistic than the other two that we looked at previously, those being the area and bar charts. Next, we'll take a look at working with animated charts. Welcome to video 6.4 of the Mastering PrimeFaces video series. In the previous video segments, in this section, we have seen various different charts that PrimeFaces has to offer. Specifically, we took a look at creating an area chart, bar chart, and pie chart. There are many more chart types available, and each of them is set up very similarly to the ones that we have already looked at. I recommend you taking some time to look through each of the different chart types that are available in the PrimeFaces showcase so that you can find the chart that best suits your needs. We're going to do something a bit different in this section, and we're going to look at the animating the charts that we have already created. Let's get started. Of course, PrimeFaces makes it super easy to animate a chart. Animation is indicated by setting the animate attribute on the model to true. It is that easy. Animations do not work on a pie chart model, so let's animate each of the other two charts that are in the dashboard now. To do so, open up the Sales Chart Controller class and look within each of the two methods that are used to create, configure, and populate our line chart and bar chart models. We will simply invoke the setAnimate method against each of the models, passing true. To keep things consistent, let's make this the first configuration after the title. Save the changes now and run the code. Let's see how it looks. As you can see, when the view loads, the charts are populated with data in an animated manner. This is a nifty effect to make the bosses happy. If we wish to go one step further, we can add another nice animation effect to our chart using the p-effect tag. We can apply the p-effect tag to a number of different components in order to add effects, such as shake or a bounce effect. For the purpose of this example, let's add a p-effect tag as a child of the first p-chart element in the sales dash view. Set the type attribute to highlight and set the event attribute to click. Let's run the application again now, and let's see the difference. When you click on the chart, it will glow or highlight momentarily. This may come in handy during a presentation or maybe just to make a flashy app for your boss. Whatever the case, the P effect makes it extremely easy. That's all there is to animated charts with PrimeFaces. By default, the charts are not animated, but it is as simple as setting a flag to add the effect. Next, we'll look at creating interactive charts. Welcome to video 6.5 of the Mastering PrimeFaces video series. In this video, we've been covering charts and animated charts. In this video, I will show you how to easily create interactive chart using some Ajax along with the PrimeFaces chart components. What do you mean by interactive, you may ask? What we are looking to do is create a chart whereby a user selects on a particular portion of the chart in order to obtain more information on the selected portion. If you take a look at the PrimeFaces showcase, you can see that the interactive charts on the site display a simple growl message, which indicate the positioning of the chart portion that has been selected. We'll take this one step further, and we will return the name of the selected component, and then we'll use the name to obtain further information from the underlying data resource. Let's get started. First, let's see how to actually invoke an action method behind the scenes. It is easy because all we need to do is embed the p-ajax inside of the p-chart component that we wish to make interactive. Then we set the listener attribute of the p-ajax tag to the action method that we wish to call upon when the chart is selected. We will likely want to set the update attribute to update some component on screen with the results of the selection. In this case, we will update a growl message in the view. To get started, open up the Sales Chart Controller class and create a private string field named Selected Pie Chart Auto Type, and then encapsulate to create accessor methods. We will use this field to store the name of the selected auto type. Next, create a public method named itemSelect, which does not return anything, but accepts an itemSelect event as an argument. Go ahead and import all necessary classes. Next, we will grab the index of the selected pie chart piece by calling upon the event argument's getItemIndex method. The item index starts with 0 and it increments by 1 for each item in the chart. Since the first item we registered with the chart in the previous segment was sedan, we will correlate that to index 0. We can see this by looking at the code in the createSalesPercentModel method. Let's create the switch statement that will process the selected item index accordingly and assign its corresponding auto type. Therefore, if the user selects a pie chart item pertaining to sedans, it will return index of 0, and we can process accordingly. In an effort of saving time, we will not make any implementations here as far as data retrieval goes. However, in a production application, one could use the selected item index to call upon an EJB or other means of data retrieval to obtain more information regarding the selected piece of the chart. Next, let's set up a Faces message that will display the currently selected auto type. We will then need to add that message to the Faces context. That's it for the Java code. Now, let's open up the Sales Dash view and add a p-ajax tag within the p-chart for the pie chart. Now, set that listener attribute equal to itemSelect method that we just implemented. Set the update attribute equal to growl, which will be the ID of the growl component that we're going to add next. Go to the top of the form and add the growl component, specifying an ID of growl. Now, let's run the code and see it in action. As you can see, when we select a piece of the pie, a message containing the auto type of the selected pie chart piece is displayed. We could go as far into details we wish by querying the data repository for more information on the selected type. That does it for this brief dive into the realm of interactive charting with PrimeFaces. The main concept is to bind an Ajax event to the chart that you wish to interact with, and then utilize an itemSelect event to glean information from the chart regarding the selected portion. That does it for section 6 on charts. While we only looked at a few different chart types, I urge you to browse through the PrimeFaces showcase and take a look at the others, specifically the bubble chart, donut chart, OHLC, and candlestick, combined chart, and multi-axis, as each of these charts offers a different visual representation for your application data. The zoom chart is also nice for allowing one to zoom on a particular portion of data. In the next section, we'll be taking a look at menus and multimedia. Thanks and have fun. Welcome to the 7th section of the Mastering PrimeFaces video series. In this section, we will be looking at different components that allow us to create menus for our applications. We will also take a look at working with some images in our applications. In video 7.1, we will learn how to create a drop-down menu using the PrimeFaces menu bar component. We'll be adding a view to the Prime Auto Sales application, which will allow our users to create and edit a wiki page or email. If we look at the PrimeFaces showcase, we can see that the menu bar component creates a menu much like something that you've seen in a desktop application such as Office or a mail client. The menu bar can contain a series of sub-menu items, each consisting of menu item objects. The menu items can be bound to URLs or action methods that reside in controller classes. Let's get started creating our menu bar. To begin, we're going to create a new view within the administrative portion of the Prime Auto Sales application. We'll use this view to construct a mini word processing editor for constructing wiki pages and email messages. Let's begin by going to our IDE and right-clicking on the admin folder, selecting New, and creating a new XHTML file. Let's name this file messagecenter.xhtml and click Finish. Go ahead and replace the contents of our new view with those that are in the current users.xhtml view. Next, remove everything within the UIDefine element so that we can create our new view contents within. The first element should be a form, and then we will place the menu bar as the first child element of the form. We will not add any attributes to this menu. Now, for the structure of the menu, we want to create a simple editing menu with the option to create a new email or message templates. Of course, we will not fully implement this solution in this video, but imagine that we would like for this menu to provide options required for basic editing of text. Therefore, this menu will be small, but it will be good enough to get an idea for how to construct a full-fledged menu for your applications. Each menu button is composed via a menu item component. A menu item can be pressed to trigger an action method, or it can navigate to a URL, perhaps a help menu or a website for information regarding a particular function of the menu. We will add a drop-down menu as the first option, creating a file option menu much like that seen in many desktop apps. To add a drop-down, we need to add a P submenu component to the menu bar, and we will give it a label of File. We can also add an icon if we wish by specifying the icon attribute. In this case, we will assign a PrimeFaces standard icon of UI-icon-disk. If you're interested in looking through all of the PrimeFaces icons, you can visit the URL that is displayed on your screen now. Now, the submenu component creates a drop-down when added to the main level of a menu bar, but it can also create a horizontal menu when nested within another submenu. We will add another submenu within the File menu and label it New. This time, we will not add an icon. As mentioned previously, menu item components are used to add functionality to the menu. We want to add two action buttons within the New submenu, one for creating a new email and another for creating a new wiki page. Let's add the first menu item providing a value of wiki page and add an action listener attribute, which we will leave null for the time being. We'll also add an update attribute so that we can perform some partial page rendering once the button has been selected. We'll be invoking the action using Ajax, so the partial page rendering is required to change the content of the page depending upon the option selected. Let's add another similar menu item with a value of message. Provide the same attributes for that menu item. Now, let's add another option directly below the New submenu, and we'll make this a menu item of Open, which will be used to open an existing wiki page for editing. We'll actually supply null values for this menu item for the time being, as we'll be wiring it up to action methods in a few minutes. Let's add one final menu item with a value of Exit, and this time we'll specify the URL attribute rather than the action listener attribute. We want to specify the URL of the application home page, so specify a / for this attribute. Since the menu bar is going to be basic, we only require one more menu drop-down on the menu bar, Add another P submenu item as a direct child of the menu bar, directly under the File submenu. Let's provide a label attribute of Edit and an icon of UI-icon-pencil. Okay, we'll add 3 menu items to this dropdown, one for bold, another for underline, and a third for italic. Specify null action listener attributes for each of these menu items for now, as well as null update attributes. Again, we'll fill these in later. It's also possible to add other components to the top level menu bar by adding a facet with the name of options. This can be handy for adding a search field or a top level button. Anything within the options facet is added to the rightmost of the menu bar. Let's add an options facet and we'll add an input text for searching. Set the value attribute to null for now and set the placeholder attribute to search ... so that there is a watermark indicating that this is a search box. Let's simulate a logout button by adding the P command button to the options facet and setting the value attribute to logout. Let's set the action attribute to message_center_controller.logout and the update attribute to message_center_body. We know that this action method does not yet exist, so let's create it. To begin, let's construct a new controller class for use as the backing bean for the new view. Right-click on the org.packed.primeautosales.jsf package and create a new Java class by the name of message_center_controller. Once it opens, make it a JSF managed bean controller by annotating it with named and session scoped, since the scope is session-based. Lastly, make the class implement serializable. Add a new public method named logout with a void return type and accepting no parameters. In the implementation, create a string field named message and set it to logged out. Next, call upon facescontext.getCurrentInstance.addMessage and create a new faces message that contains our message string. Now, when the user clicks on the logout button, we should see the faces message displayed. That's it for the menu. Now, after the menu, we're going to create a panel with an ID of message center body. And inside of the panel, create a small panel grid to hold the labels and input text components for an email address and subject field. So let's add a 2-column panel grid, and we'll add a P output label for email, specifying a false for the render attribute for now. Set the value to email, and then create the corresponding P input text component, specifying an ID of email and a null value for now. Next, create the same pair of components for a field named subject. Again, let's set the rendered attribute to false for now. Lastly, close the panel grid and create a P input text area component with an ID of email message. Set the value to null and rendered to false. Since this is an input text area, we need to specify cols and rows. So set cols equal 150 and rows equals 10 for now. This can be tweaked later as needed. Next, let's create another input text area using all of the same attribute specifications, but this time assign an ID of wiki. Lastly, let's close the panel. At this point, since we have all the component values to null, we should be able to run the code and see the initial UI. As you can see, the menu is laid out directly above our text area, and as we hover over the various menu options, it reacts much like the menu of a standard desktop application. If you recall, we set up the URL for the exit option, so clicking that menu item will return you to the application home. Now that we have the menu UI, we can create the back-end business logic and wire up the action listeners and partial page rendering as needed. Let's go to the Message Center Controller class and add a private field of string type and name it message type. Next, create a final static string named message_wiki and assign the value of W. Create a second static final string field named message_mail and assign the value of M. Encapsulate the fields to create accessor methods for the message type field. This field will be used to determine which UI components are rendered on screen. Let's set the message type value to message_wiki initially. Now, let's set up an action method for the menu. For the sake of brevity, we'll set up a single action method at this time, and we'll wire all of the menu items to the same method. Create a public method with no return value named edit. Let's accept a string argument for this method, and we will pass the name of the currently selected menu item for this test. In the method, we'll simply create a Faces message and add it to the Faces context for display. The message will display the name of the currently selected menu item. That's it for the back end. Like I said, we're going to keep this simple for the demonstration, but in a production application, we would likely have different action methods for each of the menu items. Now that we've implemented the backend controller class, let's go back to the messagecenter.xhtml view and wire the menu up. First, add a pMessages component as the first child within the Message Center body panel. This component can be used to display our menu messages. Second, let's set the update attribute for each of the components to Message Center body, since we want to partially render that panel within the view when any of the menu items is selected. Next, set the action listener for the new submenu items to the Message Center controller.setMessageType method, passing a W for the wiki selection and an M for the email selection. Now let's modify the editing menu items by changing the action listener attribute for any of the menu components that we have set to null, so that it now points to the Message Center controller.edit name of the menu item, passing the string-based name of the menu item that is being selected. Lastly, we need to specify the rendering for our email versus wiki components within the Message Center body panel. To do so, modify the render attribute value to specify conditional using JSF-EL, comparing the message type to M or W depending upon the component that we wish to display. For instance, if the current message type is wiki, then we will hide the email, subject, and email message components. Okay, that's about as sophisticated as we will get for this menu test. Let's go ahead and save everything and run the application. As you can see, when we click to select one of the new message types, the different components change on screen. Also, when any of the edit menu items are selected, an appropriate message is displayed on screen. Note that all PrimeFaces menus can be created programmatically, as the menu metadata is defined using org.primefaces.model.menuModel instances, and PrimeFaces provides a default menu model implementation. That wraps it up for the first of the menu components that we'll dive into, the menu bar. The menu bar is sophisticated, but it does have a targeted purpose. Therefore, PrimeFaces does offer a bevy of other menu options so that you can find the one that suits the needs of your application the best. In the next video, we'll take a look at the slide menu. In this video, we learned how to create a menu that contains submenus, and each of which drop down to display more options. If you recall, the menus consisted of menu item components for invoking actions or navigating to URLs. In this video, we'll cover a slide menu component. A slide menu is visually very different than a menu bar. As you can see from the PrimeFaces showcase, it is vertically laid out rather than horizontally. When a submenu is selected, the menu animates and slides to expose more options rather than dropping down like the menu bar. When it comes to building a slide menu, it is not very different from building a menu bar at all. A slide menu consists of submenus and menu items to invoke actions and navigations, just the same as a menu bar. In this video, we'll go ahead and we'll create a copy of the messagecenter.xhtml view that we created in the previous section. And this time, we'll use a slide menu in place of the menu bar. To begin, let's right-click on the messagecenter.xhtml view, copy it, and paste it into the same folder. Note that NetBeans uses refactor copy rather than paste. Once we've copied the view, open it up and remove the entire menu bar. We will rebuild it from scratch using the slide menu this time. This should be rather quick though, because we will not be building any back-end controller changes. We'll simply be reusing the back-end that we used for the menu bar. Start by creating a slide menu component. Directly within the slide menu, add a submenu component and add a label attribute of file. Go ahead and specify an icon of UI-icon-disk. Next, let's specify another submenu as a child component of the new submenu, this time adding two menu item components within. The first menu item value should be set to wiki page. Action listener should be set to messagecenter controller.setMessageType, passing a W. And update attribute should be set to message center body. Let's do the same for the other menu item except change the value attribute to message, and for the action listener, please send an M value to the set message type method. Next, add two more menu items directly beneath the submenu. First, menu item value attribute will be open with an action listener attribute of message center controller.edit passing open. And again, we want to update the message center body when this item is selected. The next menu item value attribute should be set to exit, and a URL of / should be specified. Now we can close the new submenu and start another. The next submenu should have a label attribute of edit and an icon attribute of UI-icon-pencil. Within this submenu, we want to add three menu items. Specify the value attributes of bold, italic, and underline. For these, set all of the action listener attributes equal to message center controller.edit, passing a string to the method which specifies the menu item that has been selected. Also, the update attribute on each of these menu items should be set to message center body, just like the previous menu items. That does it for the submenu, so we can close that for now. At this point, the slide menu has been completed. It is useful to note here that we do not have an optional facet that can be applied to a slide menu, which is another difference from the menu bar. If you'll recall from the previous section, the optional facet allowed us to add additional components to the top level of the menu bar if needed. The UI for the slide menu is now complete. Save your work at this point, and since we've wired up the code to the existing backend controller class, our work is done. We can run the code and check out the menu. For those of you who did not watch video 7.1, you can go back to that video to follow along with the procedure for creating the Message Center Controller class, which is used for backing the menu item action methods and navigation. Once the application has opened, put the correct URL into the browser to open the new view, and then you can see the slide menu in action. In this section, we took a look at how to construct the slide menu component, which is useful for situations where on-screen real estate is important, since this menu provides a compact user interface with the capability of allowing submenus, just like the menu bar, or otherwise referred to as a drop-down menu. In the next video, we'll take a look at the use of the tab menu. In this video, we will take a look at the tab menu, which is useful if you'd like to display menu options as tabs within the view. Most often, the tab menu allows one to change the view content depending upon the chosen tab. The tab menu does not contain any submenus. Rather, it is useful for displaying a straight bar of different options, either horizontally across the page or vertically down the side of the page. The tab menu consists of two main components. The tab menu component itself is the parent element, and in it there are one or more menu item child components. Of course, like the other menu options that PrimeFaces has to offer, the menu item is the piece of the menu that actually makes things happen. In this video, we will create a tab menu for the Prime Auto Sales application. What we really want to do is provide a few different presentation designs to our management so that when we show them the site, they can make the final decision upon how the actual site is laid out. Therefore, we're going to make a copy of the main view for the application and change out the car, truck, SUV expandable section with a tab menu. Let's get started with the tab menu. To begin with the tab menu, simply create a copy of the index.html view and name it to indextabs.xhtml so that we can easily differentiate between the two. Once you've made the copy, open it up within the editor and then go to the section of the view where we had originally created the field set components to display the car, truck, and SUV sections. We are going to actually place the tab menu above these field set sections in the view, and we are going to change each of the field sets to a panel instead. We will end up hiding and showing the proper panel depending upon which tab is selected within the tab menu. Before we create the tab menu, let's go ahead and get rid of the field sets, making them panels instead. Change the legend attribute to the header attribute instead, and add a visible attribute to each of these new panels. Let's just set the visible attribute to true for now, but we will bind these attributes to the backend variable, which is controlled by the tab menu shortly. Now when you get to the third field set, be sure to remove the Ajax action that we originally embedded to listen for the toggle events. Now that we've changed the field sets to panels, let's add a top-level panel to surround each of these, and we'll give it an ID of AutoType panel. We will later be performing a partial page rendering using this panel. Now go ahead and create the tab menu. Start by replacing the text "Choose from the style of auto" with the P tab menu. Add a single attribute to the main P tab menu tag. The active index attribute is used to mark the actively selected tab. The first menu item in the list is assigned to index 0 and so forth. Specify the value of mainViewController.tabIndex, which we have not yet created, but we will do so soon. We're going to add 3 child elements, each of the P menu item elements, one for each of the auto styles. For the first menu item, set the value to car and specify an action of mainViewController.setSelectionType passing car. Finally, specify the update attribute and assign it to the value of AutoType panel, and also add a space between the two, placing the tab menu in the update attribute. We want to update both components each time the menu item is selected. Go ahead and create the other 2 tabs, changing out the respective portions to indicate truck and SUV respectively. Now, let's modify the visible attributes that we originally set to true for each of the panels for the auto types. Set each of the visible attributes as follows, with the first one set to mainViewController.setSelectionType EQ car, so that this panel will be visible if car selection type has been made. Set the others accordingly. Now, we need to modify the mainViewController class to add the tab index field, as well as modify the correct tab index, depending upon which tab has been selected. Start by declaring a private int field named tab index. Set it equal to 0 for starters. Encapsulate the field so that we now have getters and setters created. Next, modify the setSelectionType method to include a switch statement, and we will switch on the specified selection type value. In each different case, we will set the tab index accordingly. Now, when this action gets invoked in the tab menu, the selection type will be set as well as the tab index. Now that the menu has been created and the mainViewController class has been updated, go ahead and build and run the application. When the application loads, be sure to change the indextabs.xhtml view and note how the tab menu looks. In my opinion, this looks a bit nicer than the field set, so the manager will probably opt for this view. Anyhow, go ahead and change the tabs and note how each tab selection color changes when a selection is made. Also note how the content panels are hidden and displayed according to the tab that has been selected. Too easy. That does it for the tab menu. It's a straightforward and easy component to build and utilize. I think for the value added to the application, this menu component is definitely nice to have. Next up, we'll take a look at the context menus. You know the ones. When you right-click in the application and you receive the menu next to your cursor. Yeah, that's the one. We'll cover those in detail in video 7.4. In this video, we will look into creating a context menu. If you're not familiar with such menus, a context menu is one that appears when the user right-clicks on an area within an application. Let's take a look at the PrimeFaces showcase to see a demo of the context menu first, and then we will implement one within our application. If you look at the context menu page of the showcase, you can see that there are many different versions of this type of menu. One can create a single-tiered basic context menu or a multi-tiered context menu, much like a menu bar effect. There are specific context menus for adding to image slideshows, as well as others that are geared towards tables and tree menus. In this video, we'll create a basic context menu, although any of the context menus in the examples in the showcase are similarly created. Context menus consist of a context menu component and submenus and menu items for invoking actions. In reality, context menus are very similar to many of the other menus that we've already looked at. One attribute that makes the context menu component special is the For attribute, which can be specified at the context menu level to assign the menu to a particular component. This is how the image, data table, and tree table examples in the showcase work. Another thing to note about menus is that it is possible to create many of them, including a context menu, programmatically as well, rather than JSF markup. We'll take a brief look at doing this as well. Let's get started. Let's get started with the context menu by identifying the type of menu that we wish to create for the Prime Auto Sales application. What we want to do is set up a menu on the messagecenter.xhtml view such that the context menu can be invoked from within the wiki input text area component in order to specify formatting for the text within the component. Go ahead and open up the admin/messagecenter.xhtml view. Let's add a p context menu component directly underneath the wiki or email message input text area components. Specify the for attribute and set it to wiki so that this context menu is bound to the wiki component. Next, let's add a menu item for each of the 3 editing functions that we wish to provide: bold, underline, and italic. Set the value of each menu item accordingly, and set the action listener equal to messagecentercontroller.edit and bold, respective to the menu item that you're configuring. Lastly, specify the update attribute and set it to message center body. Once we've gotten all 3 menu item components created, go ahead and run the application. Once the application is up and running, navigate to the messagecenter.xhtml view and open a wiki. Try to right-click in the text area and you'll see that the context menu appears. Make a selection and you'll see the message updated. Now that we've seen how to create a contextual menu using the standard PrimeFaces UI tags, let's dig into how we can do this programmatically. All PrimeFaces menus can be created programmatically as the menu metadata is defined using org.primefaces.model.menu instances, and PrimeFaces provides a default menu model implementation. The model can then be bound to a menu component by specifying the model attribute. Let's take a look at programmatically creating this context menu that we previously coded using markup. Create a new class within the Bean package and name it Menu Bean. Next, open up the Menu Bean and create a private field of type Menu Model, naming the field Model. Fix the imports and create the getter method for the model. Next, create a public method named build returning void. In the method implementation, instantiate a new default menu model and assign it to the class member model. Next, create a new default menu item object and name it bold item. Pass the name edit to the constructor of the default menu model. Once the object is instantiated, set the command by calling setCommand on the object and pass the string-based JSF-EL for invoking the edit method, messagecentercontroller.edit, and then the word bold. Finally, call the setUpdate method on the object and pass the ID on the view that needs to be updated. Repeat this step for the other 2 menu item objects. Lastly, call the model.addElement method, adding each of the menu items separately. Now, go ahead and invoke the build method within the class constructor. Now go to the Message Center controller and create a new private field of type Menu Bean, name it Context Menu. Initialize it by instantiating a new menu bean. Next, create a getter for the context menu field. The menu model is now ready to wire to the UI. Open up the messagecenter.xhtml view and go to the p context menu component. Remove all of the menu item components and add a model attribute to the context menu, setting it to messagecentercontroller.contextMenu.model. Once complete, save and run your code. Note that the context menu still works as it did when we originally generated it using JSF markup. In conclusion, the context menu provides a convenient option for adding extra functionality into your application without the risk of taking up real estate. As we've seen in this video, the context menu consists of the context menu component, along with 1 or more menu item child components. We also discussed and demonstrated how it is possible to generate the model for PrimeFaces menus programmatically. You can use similar programmatic approaches for any of the other menu components as well. That's it for the context menu. In the next video, we're going to take a look at the last 2 menu types that we'll discuss in this video series, those being the panel and tiered menus. In this video, we'll be covering two menus that are very similar to each other, with a couple of key differences. First, we'll take a look at the panel menu, which provides an elegant hybrid of the accordion and tree components. The panel menu is great for creating a menu that contains more than one section of options, allowing each section to be collapsible. After we take a look at the panel menu, then we'll cover the tiered menu, which displays submenus in overlay panels, creating a visually appealing collapsible menu. First, let's begin by creating a panel menu within the Prime Auto Sales application to contain options within the MessageCenter.xhtml view. We will utilize the same menu item components within the panel menu that we used when we previously created the menu bar in the original Message Center view. Let's get started. We want to create a copy of the MessageCenter.xhtml view and rename it to Message Center Panel Menu. Once we have created the copy, go ahead and remove the P menu bar component and all enclosed elements. Next, we're going to add a P panel menu element into the same location where we just removed the menu bar. A panel menu uses submenus to group its elements, so we're going to want to create two submenus within the panel menu, and those submenus will be used for indicating the document type and for editing. As such, we'll create a first P submenu element as a child of the P panel menu and specify the label attribute, giving it a document type label. Next, create two menu item components within the submenu, and these will be used to switch between the email message and the wiki. Provide a value attribute for each, along with specifying the action listener attribute and setting it equal to MessageCenterController.setMessageType and the letter W, or MessageCenterController.setMessageType passing the letter M, respectively. Lastly, set the update attribute on these menu items and set it to MessageCenterBody. Now, go ahead and close the first submenu element and create the second. Provide the label Edit for the second submenu element. This time, we'll create the three editing menu item objects, bold, italic, and underline. Set the value attributes accordingly, and set the action listener attributes equal to MessageCenterController.edit method, passing the respective editing string, and lastly, specify the update attribute and set it to MessageCenterBody. Close the second submenu at this point. We've now completed the panel menu. Simple, wasn't it? Go ahead and run the code. Once the application has been deployed, be sure to load the correct URL to MessageCenterPanelMenu.xhtml view into your browser. What? What's this? It doesn't look right now, does it? The panel menu will take up as much width as the largest component within the same portion of the view that it is in. Therefore, it is taking up the entire width of the text area component. We can easily resolve this issue by wrapping in the P layout. Go ahead and add the P layout and the closing P layout just before the opening form and the closing tag below it. Next, add a P layout unit tag just before the opening panel menu tag, and we will set the position attribute to west. Add the closing layout unit tag after the panel menu. Let's open another P layout unit directly below and set the position to center. Add the closing P layout unit after the Message Center body panel. Now, as you can see, the panel menu is simple, yet it looks great. It provides a nice menu for our view. We just need to place it strategically within our view. Now we will have some fun with the tiered menu. In order to show you just how similar these menus are, we're going to merely make basic changes to the original menu bar to create the tiered menu. Having the ability to easily change between different menu types allows the flexibility while developing your application, giving you the option to see more than a single menu in your application pages. Again, let's start this exercise by creating a copy of the MessageCenter.xhtml view and renaming it to MessageCenterTieredMenu.xhtml. Next, simply open up the newly copied view and rename the P menu bar elements to P tiered menu. Next, remove the optional facet from the menu. Click Save and run the code. When you run the code, you can see that the tiered menu treats the submenus as an overlay menu. We could actually use it to wrap this view in a P layout as well to make it look better, but this will do for the demonstration purposes. Remember, each of these menus can also be created programmatically via Java. If using a model, simply set the menu's model attribute accordingly. rather than embedding the submenus and menu item objects. Let's take this opportunity to also look at a few of the additional attributes that are part of the tiered menu. If you go back to your IDE and you press the spacebar within the P tiered menu component tag, you can see the autocomplete dropdown of the other possible attribute choices. As you click on the down arrow, you can cycle through each of the attributes, seeing the information from the Java doc in the preview window. For instance, if we select the auto display attribute, we can see that this provides the ability to turn off the hovering feature of the tiered menu and force the mouse click to show the overlay submenus. Another nice attribute is overlay, which can be used to specify where the overlay will appear when it is displayed. While developing your application menus, take the time to learn each of the additional attributes, as they may prove to come in handy under certain circumstances. That does it for the menus of Section 7. We covered quite a few menus, and these last two were nice to have near the end to round things out. Next, we'll take a look at two multimedia components, the image switch and Galleria, which are used to display images within an application. In this video, we'll take a look at some useful components for displaying images within your applications, those being image switch and Galleria. If we look at the PrimeFaces showcase, we can see that the image switch provides a convenient way to page through a series of photos, either using a button to switch or using an automatic switching system. The Galleria provides a similar switching functionality, but it also provides the option to display thumbnails at the bottom of each viewer. Each of these components has their own use case, but both can come in handy in various situations. We'll first take a look at the image switch. The image switch component provides a great way for users to page through a list of photos. There are various ways to create the list of photos, be it by photo name, referencing a URL, a binary object in a database, or by other means. But whatever the way in the end, the list is bound to the image switch, much like that of a data table. The image switch then traverses over the list of photos and displays them using a P graphic image, which points to the current photo in the list. Let's start by opening up the automobile.xhtml view. Within this view, we'll create our image gallery comprising all the different vehicles that we have to offer. We want the users to see the image gallery right away, so we'll place it at the top of the view. In this example, we're going to be displaying JPG files that are stored within our project. To be specific, they're stored within the resources/images/sedan folder, and they are named sedan1.jpg, sedan2, and sedan3 accordingly. That said, we're going to create a list of photo names within the Prime Automobile Controller class. Go ahead and open up this class and create a private field of type list string and name it to sedan images. Next, encapsulate the field so that we have public accessor methods. Now, within the load automobiles method, we will populate the list of sedan images. If we wanted to, we could store the list of image names in the database and read from there. For the purposes of this test, we'll go ahead and we'll hard code the image names. Within the load automobiles method, simply create a new array list and assign it to the sedan images field, and then add these three string-based image names to the list, including the path to the image. For instance, the first image name will be sedan/sedan1.jpeg. Once we have done this for all three images, we have completed the sedan images list and we're ready to code the front end. Open the automobiles.xhtml view again and add a PImageSwitch component as the first child within the form. Next, add a widget var attribute and name it sedan images. We wish to add an effect for when the image is switched, so add the effect attribute and set it to fade. Look into the documentation for all the available options. Finally, set the slideshow auto attribute to false, otherwise the images will change on their own. We're going to attach a couple of buttons to the image switch in order to control the paging of the images. We'll do that in a minute, but first, let's add the list to the image switch. Now, we add the list by actually embedding the UI repeat tag within the component and setting its value equal to the list we wish to traverse. Therefore, add the UI repeat and set the value to primeautomobilecontroller.sedan images, and then set the var attribute to image. Lastly, give it an ID of switcher images. Next, embed a P graphic image inside of the UI repeat and set the library to images, since that is the directory within the resources folder that we wish to use. Set the name attribute to images, since our string within the sedan images list contains the path to the image, and set the ID to image. Now, we need to add the controller buttons for the image switcher. You can do this by adding two P command button components underneath the image switch, one for controlling the forward paging and another for controlling the backward paging. Set the type attribute on these command button components to button and set the icon for the back button to UI icon circle triangle W and set the ID to PREV. For the control, set the onClick to PF passing sedan images string dot previous, as this is the PrimeFaces JavaScript handler to move the control backward. For the forward control, set the icon to UI icon circle triangle E and set the ID to next. And lastly, set the onClick attribute to PF passing sedan images string dot next. At this point, we can save and run the code. When you load the application, go down to the car section of the index view and click on the View Cars button to open up the automobile.xhtml view. Now, at the top, you should see the image switch. The forward and reverse buttons should control the paging of the images. You can easily modify this behavior of the image switch by changing a few attributes of the image switch component tag. Effect can be changed to make transitions different, and slide auto show can be changed to true in order to make the images switch on their own. That's it for the image switch. Now, let's compare this to the Galleria component. The Galleria component is very similar to the image switch in that it provides an elegant way to page through images. However, I think that you'll find that working with the Galleria is much nicer, almost like an upgrade to the image switch. You'll see what I'm talking about in just a minute. The Galleria works in a similar manner in that it traverses over a list of images, and those images can be loaded in any way you like. A big difference between the Galleria and image switch is that there is no need to embed a UI repeat within the Galleria. Everything's built right into the Galleria tag, so you set the value, the var, and you're on your way. This also includes two command button components that are needed with the image switch to switch forwards and backwards through the images. Let's utilize the same data list that we use for the image switch. So we'll just work on the UI for the Galleria. Open up the automobile.xhtml view if it's not already open, and get rid of the image switch component, along with the two command buttons that were used for paging with the other component. Now, create a new Galleria component by adding a pGalleria tag, provide an ID of sedan images, a value of prime automobile controller.sedan images, and let's also add the nice show captions attribute and set it to true. We can actually assign captions to each image if we wish. Now, embed a pgraphic image inside of the Galleria and provide a library attribute set to images, a name of image, and set the title attribute to image as well, so that the image name will show as the caption. Now save and run your code. As you can see after running your code, Galleria displays thumbnails of all the images across the bottom, and it is all contained within a nice package. However, the image does not fit in the viewer by default. We can change this by specifying the panel width and panel height attributes. Go ahead and specify each of these within the component in our view and set the height to 200 and the width to 250 just for grins. Now, when you reload the application, you'll see that it fits much more nicely. As with all the PrimeFaces components, there are a bevy of attributes that we can use to customize our component. Specify the effect, effect speed, show caption, etc. As a matter of fact, let's go ahead and specify the effect equals fade and show caption to true. Rerun the code and see how nice it looks. If you don't like the thumbnails across the bottom, this can be removed by specifying show film strip and setting it to false. Both the image switch and Galleria components provide convenient options for displaying your images. This video covered implementing the image switch and Galleria for our application. In this section, we took a look at many menu options that PrimeFaces has to offer, as well as some multimedia features for working with images in your applications. In the next section, we'll dive into the PrimeFaces Ajax framework. Welcome to video 8.1 of the Mastering PrimeFaces video course. This is the first of 4 subsections which will cover PrimeFaces Ajax functionality. In this video, we'll cover some basic PrimeFaces Ajax functionality, including the ability to set values from a client view into controller fields without performing a round trip to the server, as well as the ability to invoke an action method within the controller without performing a classic form submit. To get started, let's first briefly describe what Ajax means. To perform an Ajax action within an application view refers to the ability of a view submitting values, updating view content, or invoking server actions without the requirement to perform a server round trip. Ajax relies upon JavaScript in the browser to work with the DOM and perform a call to the backend for submitting values or invoking functionality. It also relies on the backend classes to update field values and then return a response to the client, which initiates a partial page refresh. The idea being that only the required portions of a page are updated, not the entire page. Does that make sense? If not, please refer to the online documentation to gain a better understanding. There are plenty of documentations available. PrimeFaces exposes Ajax behavior through many of its components by default. For instance, the command button will perform an Ajax request by default if it is clicked. One must explicitly disable this functionality by specifying a false for the Ajax attribute of the command button if one wishes to do so. PrimeFaces exposes Ajax behavior to input fields via the use of the pAjax tag, which is referred to as the Ajax behavior component in the PrimeFaces documentation. This tag is an extension of fAjax, providing more functionality than the standard. The Ajax behavior component exposes Ajax through actions upon events, listeners, and form submissions. For instance, let's imagine that we wish to create a form that was able to mirror the text that was being typed into the input text component. This is what we're going to do by embedding the pAjax component within one of the input text components in the AutoQuote view. Let's take a look at this functionality by adapting our AutoQuote view to contain a new expression that we can use to display the content of the current form's first name field. Go ahead and add an EL expression inside the value attribute of output text and provide the ID of text mirror. Next, embed an Ajax behavior, the pAjax tag, in the first name input text component as such. Add an update attribute and set its value to text mirror so that it matches the ID of the output text component that we just added to the view. Set the event attribute of the pAjax tag to key up. Now go ahead and run the application. It seems that we do not have a way yet to navigate to the AutoQuote view since our managers have not yet decided where to add it. So type the URL to this view into the browser. Now when the page loads, type some text into the first name field and see the results mirrored above it. This is due to the Ajax behavior submitting the field content to the bean when it changes and then updating the view using the partial page update. Pretty slick and easy to implement, right? Now that's all nice, but what if we wanted to invoke an action on the server when the text within an input field changed? This is easy to implement. Simply change the pAjax tag to include a listener attribute and set it to the controller method that you wish to invoke. In this case, let's add a method named reflectText to the Prime AutoQuote controller. Let's make it a public method that returns void, but simply prints out the contents of the first name field to the console. Go ahead and save, and then run the program. Type a word into the field, and then move out of that field, and you'll see the text displayed in the admin log now. How easy was that? Now, we have an Ajax listener bound to an input text field, and we did not even have to write any JavaScript code. Now let me show you how easy it is to Ajaxify your entire form so that when you fill in the text and hit the submit button, the entire form is submitted without refreshing the page. Only portions of the page will be updated as per the specified component IDs. First, ensure that the pMessages component in the view has an ID so that we can reference it for update when the action method is completed processing. Next, let's remove the output text component that we added to the view, as this is just for testing. We can also remove the Ajax behavior component from the first name input text field. Now, all we have to do is remove the Ajax attribute from the command button and ensure that the update attribute specifies the ID of the component that we would like to update. In this case, the messages component. Fill in the form and then click submit. Now you can see that the message is displayed, which provides feedback to the user. The PrimeFaces command button is set to be Ajax enabled by default, so we don't even have to specify any attribute to enable this functionality. Now what happens if this is a long running process and the UI does not do anything for some time? For these cases, it is a good idea to include a progress message for the user to see what is happening with the processing task. PrimeFaces provides you this for free with the Ajax status component. This component is very easy to use and flexible as well. What it does is provide an animated progress bar when an Ajax action is occurring. Let's go ahead and add the Ajax status component to the AutoQuote view. At the same time, let's also add a bit of client-side validation to the form by setting all of the fields to be required. Go ahead and open the AutoQuote view and modify each of the PrimeFaces input text components, adding a required equals true for each. Next, add a p-Ajax status component to the top of the view directly within the form. As a child of the Ajax status component, add the facet name equals start and put the text working inside. There are three facets that can be set for the Ajax status component, those being default, start, and complete. Anything in the default facet will show up before Ajax activity begins. Objects or text within the start facet will appear once Ajax activity begins, and those in the complete facet will appear once the work is complete. Lastly, let's add a little time to this save quote method by opening up the Prime AutoQuote controller and adding thread.sleep and passing 3000 to the method. This is normally not a good idea for production deployments, but it will be good to see our Ajax status message on the screen. Fire up the application and navigate to the AutoQuote view and enter some information into the form. Once we press the button, you should see the working message displayed. Now, this can also be an animated GIF, which is usually the case. I'm sure that you've seen the progress bar for showing in Hourglass before. We could do that as well. For now, this text just does the job. That's it for the first section on Ajax. In this video, we learned how to basically apply Ajax functionality to our application forms. In the next video, we'll take a look at applying listeners to our components. In this video, we'll take a look at two of the Ajax-oriented PrimeFaces components. Although we are only covering two of the components in this video, there are many Ajax-oriented components available via the PrimeFaces library of UI components. This video is meant to provide you with a fundamental understanding of the power that can be added to your applications via the use of Ajax-oriented components. Specifically, we'll look at two of the most useful Ajax components in my opinion. First, we'll look at the poll component, which could be used to execute a remote server-side method on a periodic basis, and then update the UI once the method has completed execution. After that, we'll look at the fragment component, which can be useful for performing partial updates when Ajax requests are processed. Let's get started. The poll component is one that people find most handy as it allows for the periodic execution of a server-side method, followed by an update of specified components within the UI. The use case for such a component is fairly easy to understand. Imagine that you're making a remote database call and that it may take some time to return your results. So you wish to check the server periodically to see if the results have been returned. Or perhaps you're making frequent data calls and you wish to update your view each time the data changes. The poll component can be useful in these scenarios to periodic call execute a method within a controller class and update the DOM once the database processing is complete. Let's add some functionality to our Prime Auto Sales application that will allow the user registration listing to update automatically so that we can keep an eye on our interested users. Go ahead and open up the current users.xhtml view and we'll see that there is a current user listing. What we want to accomplish is the execution of the user registration controller.populateUsers method on a periodic basis. In this case, we will set it to 30 seconds. Therefore, add the p-poll component directly inside of the form on the current user's view. Set the auto start attribute to true so that the polling begins when the view is loaded. Set the delay to 600 as we wish to have the polling occur every 600 milliseconds. Set the listener to the user registration controller.populateUsers method. This will load the latest list of users into the user list. Lastly, set the update attribute to registered user list, which is the ID of the table that is used to display the current list of registered users. When we save and run the application, the polling will begin on page load. Open the browser to the admin/current users view. Next, open another browser and register a new user to the system by entering the user into the user registration form. After the specified delay period, we should see the data table update to include the newly registered user. The poll component comes in very handy for performing remote method calls and periodically updating the view in areas that need to reflect changes. It is useful to note that we should also pay attention to all of the other useful attributes of the poll component, just as with the other PrimeFaces components. For instance, the async attribute specifies whether Ajax requests should be queued or not, and it is also possible to set listeners to be invoked on life cycle events. That does it for the poll component. Let's move on to the next component. Next up, we have the fragment component. This one is useful for performing a partial update on only selected components within a view. The fragment component actually encapsulates all of the components that should automatically be updated due to an Ajax process. Those components within the fragment must be Ajax enabled. Once encapsulated, only those components that are children of the fragment will be updated. Let's get started with the fragment demo. To start, make sure that you're located within the autoquote.xhtml file, and we will encapsulate the first four fields: first name, last name, phone, and email with the fragment component. Set the attribute of auto update to true. Move the P panel grid inside of the fragment component, setting the columns equals 2 for layout. Let's add a new button after the closing panel grid, and will still be inside of the fragment. Now create a new command button after the panel grid but inside of the fragment. Set value equals validate user and set the action listener to PrimeAutoQuoteController.checkValid. Now open the PrimeAutoQuoteController class and create a new public method that returns void and name it checkValid. In this method, simply print out to the server a log message. And add a new private string field named testMessage and create accessor methods for that. Within the checkValid method, set testMessage equals updated user. Also, obtain the request context and update the component with an ID of testMessage, the newly added message component. We will talk more about request context in the next video of this section, but for now, just know that it will update the designated components within the view. Note that we've just added the command button and output text to the form for the purposes of this demo. We can remove them after we've finished testing. Now that we've got the implementation in place, go ahead and run the code. That's it for the Ajax components section. I want to reiterate that you should take the time and review each and every component on the PrimeFaces showcase, as these components that we've just seen are only a couple of the great ones that can be utilized with Ajax. Next up, we'll talk about making remote calls via JSF views. In this video, we will look at how to achieve calls to your JSF controller methods via JavaScript within your JSF views. A few years ago, this was a very difficult task to achieve. Many times it involved smoke and mirrors techniques. Then came frameworks such as Seam that began to provide components that more easily enabled remote calls. The PrimeFaces remote command component takes this strategy one step further by allowing one to specify the remote method using EL. With this component, we can bind to a backing bean method using a simple tag. Let's take a look. Let's add the remote command component to one of the views within the Prime Auto Sales application to see how it works. What we'll do is add a site counter so that each time a visitor opens the index view, the counter will increase by 1. The counter will be invoked on the page load by a JavaScript function, which will in turn invoke a backend method within the main view controller named incrementVisitorCount. First things first, let's set up our plumbing. If you ran the creation script for the Prime Auto Sales database, you'll note that a table named PrimeVisitorCount was generated. You should also have an entity class by the same name. What we would like to do is implement a method within the main view controller that will increment the counter by 1 each time the main view is visited. We will not get too in-depth with our logic in this example, but in a production use case, it would also be beneficial to add logic to determine whether this is a unique visitor versus someone who had visited the site several times in the same day. Add a method to the main view controller named incrementVisitorCount and also inject the PrimeVisitorCount facade EKB into the class. Next, within the PrimeVisitor facade, let's create a new method named incrementCounter, which queries the database for the most recent count and then increases it by 1. Next, implement the increment visitor count method that we initially added to the main view controller by calling the prime visitor facade increment counter method. Lastly, add a new method to the main view controller named getVisitorCount. Return an int from this method, and in the method call upon the prime visitor facade to find the object with ID of 1, which is the only record in the entity. Assign that object to a new field of type prime visitor count and return the count from the object as a result. Now let's implement the view. Open the index.xhtml and add a p remote command as the first child within that form. Next, set the name to increment visitor count, which can be utilized from the JavaScript call to invoke a bound action listener method. In this case, we'll also set the auto-run attribute to true, and this will invoke the command when the view is loaded. This way, we don't have to write a single line of JavaScript. Finally, set the action listener attribute to mainViewController.incrementVisitorCount and set the update attribute to visitor counter. That's it for the remote command component. Now let's add the visitor counter component to the view by scrolling down within the index.xhtml and adding an output text as the final element in the form. Let's set the ID equals a visitor counter and the value equals mainViewController.visitorCount. That's it. Now it's time to run the code. Load the application in your browser and hit the refresh button a few times. Scroll down and note that the counter is incrementing on the page. This is because of the remote call. As you can see, this can be a very easy way to call upon a method that resides within a backing bean from within your view. If we wanted to create a JavaScript function that was executed on page load, we could do so and then invoke the increment visitor count from within that method in order to initiate the remote call. The name attribute of the remote command component acts as a handle for invoking the remote command via JavaScript. That wraps it up for the remote command component. It's an easy component that enables powerful functionality within your applications. Next up, we'll cover the request context object in a bit more detail. In this video, we will discuss and demonstrate the request context. This is a helper object that provides the capability to interact with components within a JSF view from your backing bean methods. For instance, using the request context, you can execute JavaScript code within the currently loaded view, add alert messages, and more from within the server-side Java code. In this demonstration, we will utilize the request context to execute some JavaScript, which will open a dialog in the view and also disable and re-enable components from the Java method. Let's get started. We will modify the Prime Auto Sales AutoQuote view in this demonstration such that we will add a dialog to the view which will open when we perform a user validation, and it will automatically close when the validation is complete. If the validation is successful, the Validate User button will become disabled. We will open and close the dialog as well as disable the button from within the Java code using the request context object. First things first, let's open up the autoquote.xhtml file and add a dialog inside of the form element. Set the widget var of the dialog to progress dialog, and that should be the only element we need to specify at this time. Let's keep this basic. Next, we'll go down to the view and we'll take a look at the command button that is labeled Validate User. Specify widget var for that component and set it to client validation so that we can get a handle on it from within our Java code. Now, if you don't have this button on your form, we added this in video 8.2 of this series, so you can easily find out how to implement this button by viewing that video. Next, let's take a look at the method that is bound to the action listener of that button, the PrimeAutoQuoteController.checkValid method. In video 8.2, we use the request context to update the test message output text component on the form once it was completed with processing. Let's modify that method so that the request context is created first, and then we will call its execute method to run a JavaScript command which will show the dialog that we added to the AutoQuote form, identified as progress dialog. So the text we will use to invoke the JavaScript is pf, passing the progress dialog string .show to utilize the PrimeFaces JavaScript framework. Next, let's add a callback parameter to specify some value that will be passed to the client. Do so by calling upon the context.addCallbackParam. Let's simply pass a string of new value and assign a value of true by passing it to the string value pair separated by comma to the add callback param. Now, let's go to the end of the method and we'll add another execute invocation. This time we will close the dialog by calling pf passing the progress dialog string .hide. Lastly, we want to hide the validate client button when the validation is complete. So invoke the execute again and this time set pf passing client validation string .disable. On the client side, we need to process the callback parameter. To do so, we need to add an onComplete attribute to the form's button and specify a JavaScript function to execute after the completion of the method. Let's call the function handleRequest and pass 3 arguments, xhr, status, and args. Now let's implement this function. To do so, go to the template and then to the header section and add a new function named handleRequest, accepting the 3 parameters that are passing from the onComplete callback handler in the command button on the autoquote.xhtml form. Now, within the function, let's issue an alert and pass the value of args.newValue parameter. This should invoke an alert on the client that reads true once the action is complete. This is a very simplistic example of callback parameters, but you can see that it is very useful for passing data and objects alike from the server side back to the client. That's it. Let's run the code now and see if our dialog appears when we click the button. Go ahead and load the application. Now visit the AutoQuote form and enter some information from the user. Then click the Validate User to see the magic. Now, note that we did not even see the dialog, but the button was disabled. This is because there is not enough activity to actually pause the view to display the dialog. Therefore, let's cheat and add some activity, or pause, by adding thread.sleep 4000 inside of the checkValid method after we open the dialog. We then want to surround it with a try and catch. Now let's run the code again and you should see the dialog now since we have implemented a pause. Let me just say that this should not be done in a production application. It's just for testing. That's all we will cover for the request context. I would simply like to state that the request context can become a very important part of your application, especially if you wish to create rich user interfaces that react based upon server-side activity. That's it for section 8 of this video course. In this section, we learned how to utilize basic Ajax and event Ajax, the remote command, Ajax components, and the request context. In the next video, we'll take a look at the selector framework. In this video, we will discuss and demonstrate the ability to use PrimeFaces search expressions along with the selector framework. Specifically, in this video, we will cover how to provide an expression to reference components via selectors when performing a view update, and also how to exclude selected components from an update. Let's get started. The selector framework is enabled using the jQuery Selector API. This is a JavaScript-based framework for providing expressions in order to search and update or exclude from update only those form elements or components that you desire to have processed. Let's take a look at the PrimeFaces showcase and see a simple example. Take a look at the selector. You can see there is a simple form on the showcase. However, looking at the code, you can see that the update and process attributes of the buttons contain expressions that look quite different than any others that we've used in this video series thus far. These are selector API expressions. The ampersand character signifies the start of a selector expression, and within the expression, you can include the component type that you wish to have updated or processed. For instance, in the example, you can see that all of the UI panel components will be updated when the third button is pressed. However, in the last button, all components within the UI panel will be processed with the exception of the select components. Let's provide a quick example of using a selector expression to update our quote form. Let's begin by opening the AutoQuote view, and let's first utilize a special keyword of the form to update all form elements when the command button is pressed. To do this, replace the contents of the update attribute with ampersand form. Now go ahead and run the code and you'll see that it still displays the message as expected, because all form components are being updated. Next, add the process attribute and then provide the expression &form : last name to process only the last name field. Now run the code and submit the empty form. You will see that only the last name field is processed. Open up the view code again and update the expression to exclude the radio component using the syntax open paren input : not open paren radio close paren. Now when you run the form again, all components within the first child element of the form are processed with the exception of the model radio button field. That does it for our brief look into PrimeFaces search expressions. These expressions can really enable one to get very granular in the components or form elements that are processed or updated. These expressions can also come in handy in many other areas as well, such as CSS. Please look through the jQuery documentation for more information, and also search online for examples, as this feature is not very widely documented. That's it for Section 8 of the video series. In this section, we learned how to utilize basic Ajax and events, remote command, Ajax components, the request context, and search expressions via the selector framework. Welcome to the 9th section of the Mastering PrimeFaces video course. In this section, we will briefly be covering 3 PrimeFaces features and side projects that have significant impact on the applications you develop in PrimeFaces. In the first video, 9.1, we will be providing a brief overview of the PrimeFaces mobile components. In releases of PrimeFaces prior to 5.0, PrimeFaces Mobile was a bit of a side project that you had to install and configure it separately from the rest of the standard PrimeFaces library. This was no longer the case for PrimeFaces 5, whereby a single PrimeFaces download contained everything required to build standard and mobile applications for the web. If you think about it, transitioning from a standard desktop browser development to mobile development can be quite a task, as it takes a lot of time and patience to develop a user interface that works well on a mobile platform. Oftentimes, developers end up producing 2 or more applications to tackle the same problem from both the standard desktop browser or a mobile device. And oftentimes, these separate mobile and desktop applications must be written in different languages as well, which can become quite pricey if your organization does not have enough funding to spend on development. PrimeFaces Mobile aims to improve this issue by providing a set of mobile components as well as a mobile render kit for generating JSF views that can be used on a mobile device. This means that organizations can simply develop a single code base that can be used for both desktop and mobile browsers. All that aside, PrimeFaces Mobile contains its own render kit, and as such, many of the standard PrimeFaces components are altered to work better on mobile devices. Built on jQuery Mobile, the components are optimized to become responsive and scale well on mobile devices. In this video, we'll take a look at a number of the components that are optimized for mobile, and we'll build a small mobile view for the Prime Auto Sales application. Now that you have a general understanding of the concept behind PrimeFaces Mobile, let's dive in and use a few of the mobile optimized components to build a mobile view within the Prime Auto Sales mobile application. First, we have to apply a liner for configuration in our Faces config file. You need to add a mobile navigation handler, which I've already done here. Next, we want to ensure that we have a clean separation between the mobile and standard browser views. So let's add a new folder to our web pages in which we'll place the mobile views for our application. Let's begin by adding a new folder and name it Mobile. Next, we want to apply a standard template across all of the mobile views as we did with the standard web application for a normal desktop application. But we don't have enough time to go into that, so we will add a mobile render kit directly into the XHTML file as opposed to in a template. Therefore, what we want to do is recreate the view for obtaining a quote, as well as the current registered users view in a mobile format. Let's build a mobile view for the auto quote form in this section. To begin creating the view, add a new XHTML view named auto quote into the mobile folder. Next, copy the sources from the standard autoquote.xhtml view and paste them into the mobile autoquote view. Next, remove the template from the newly created view and add an fview renderKit equals PrimeFaces_mobile renderKit to the view. What we need to do next is mark the page as mobile by surrounding the content within the PM page tag. Now, it is important to note that a single view can contain more than one PM page tag and therefore more than a single page, but in this case, we will stick to one. A mobile page also contains a dedicated header section, which is delimited by the PM header tag. In this case, simply add the text "request a quote" into the header. Lastly, the content section is delimited by the PM content tag. All the components will be rendered as a part of the content portion of this page. It is also noteworthy to mention that instead of using the table layout or panel grid layout on mobile, PrimeFaces Mobile contains a PM field tag, and this can be used to pair a label with a component. Let's change the view to wrap each label component pair with a PM field tag. Now, let's leave the rest as is and run the application. You'll notice that the view looks a bit different as each of the input elements are now styled in a mobile design. Let's use the NetBeans Chrome plugin to scale the view down to a smartphone portrait size, and you'll see that the design is responsive. The text fields resize automatically. One of the standard components that has a completely new look on mobile is Select One Radio. If you scroll down to take a look at the Model section, you'll see that the radio buttons have much more area, allowing them to be more easily selectable via a finger. So, as you can see, without even changing the components, the PrimeFaces Mobile Render Kit alters the way in which standard components are displayed and sometimes also how they function. One of the most often used components for mobile is autocomplete. Let's face it, the less a person has to type on a mobile application, the better. Let's move down to the Make field and notice how it contains a magnifying glass. That icon is used to signify that the field is autocomplete enabled. Begin typing Acme and you'll see that it is completed for you, allowing for easy entry. Another nice mobile layout change is that the default button will now span all the way across the view. Now this can be changed if needed for some situations by simply adding the inline attribute to the button. Also note that the Ajax still functions in the same manner that it would in a desktop application. Plus there are additional Ajax capabilities within the PrimeFaces Mobile Render Kit. For instance, there is an Ajax status component bound to each view out of the box. No need to add one in. Also, since PrimeFaces Mobile is based on jQuery Mobile, it brings with it a few idiosyncrasies. For instance, jQuery Mobile initializes all components at page load by default, and if any state changes, then the components must be manually refreshed. Otherwise, they'll not be enhanced for mobile. PrimeFaces Mobile hides this by providing Ajax support for all components under the hood. Well, this has been a whirlwind tour of PrimeFaces Mobile to get you up and running quickly. We've covered the basic concept behind mobile views. We also covered the stages of configuration that are required for PrimeFaces mobile applications, as well as how to lay out a single-page mobile view. In the next video, we will focus on navigation, and I'll show you how to add more than one page to a view. Welcome to video 9.2 of the Mastering PrimeFaces video course. In the previous video, we began to take a look at the PrimeFaces mobile API, which is built on top of the jQuery mobile library. We learned how to generate a basic mobile input form using components that are optimized for mobile use. Although it is quite possible to generate entire mobile applications using a separate view for each page of the application, it is not very efficient in some cases, especially given that smaller views are more appropriate for mobile devices. For instance, if you have a single view within a standard web application on the desktop that includes a side menu that opens up subviews, this can be cumbersome to navigate on a mobile device. PrimeFaces Mobile and jQuery Mobile aim to make this easier on mobile by allowing one to include multiple pages within a single view. That is, a single JSF view can contain any number of PrimeFaces mobile page sections. Each separate PrimeFaces mobile page can contain its own header, footer, and content section. How do we navigate between these separate pages? Well, we can navigate using menus with links or command buttons, just as we would in a standard JSF application that includes a separate page for each view. However, the mobile framework has optimized navigation for better use on these multi-page views, and includes the ability to provide slick-looking animations when views are being navigated. In this video, we'll first take a look at the standard navigation between two separate mobile views, and then we will look at creating a single JSF view that contains multiple mobile pages. We will then look at how to navigate between those pages. To begin, let's create a second mobile view within a newly created mobile folder. Simply right-click on the folder and create a new XHTML file and name it second.xhtml. To make this quick, copy the contents of the mobile/autoquote.xhtml view into this new view. Now go ahead and select everything in the new mobile view that is contained between the PM content section tags. Delete that content and add the text second mobile view. Okay, now we have two mobile views. Now let's create a link from the first view to the second view. Go to the first mobile view and add a new command link after the form inside of the new form. Set the value to second view and set the action to prime autoquote controller dot navigate to second. Now go to the prime autoquote controller class and create a new public method that returns a string and return the string second so that we can navigate to the newly created second mobile view. When we run this code, the link now takes us to the second mobile view, just as a standard JSF application navigation would occur. Performing standard JSF navigation is no problem, but it is also not as seamless of an experience as we would come to appreciate on a mobile application. With that said, the PrimeFaces mobile framework allows us to navigate between mobile page constructs that reside within a single view and apply animation during the navigation via Ajax. To get started, let's open up the autoquote.xhtml mobile view again, and this time let's add a second PM page construct after the first. Let's specify an ID of second for the second PM page and add an ID of first to the initial PM page. In the second page, add a simple header that contains the text second page of multi-page view, and then add a content section that contains a p-link with an outcome attribute set to PM first and a value of back. That said, modify the action that is bound to the command link on the first page so that it contains a return value of PM second. The last thing you need to do is ensure that the command link is modified such that the Ajax attribute is set to true, or you can remove it altogether, as true is the default. The beauty of using a single view to constitute more than one mobile page is that navigation can take place using Ajax. This creates a more seamless user experience, especially on a mobile device. Now run the application, click on the link for the second view, and note how quickly the navigation occurs. Click on the backlink and note that you are now taken back to where you started. Not bad, eh? Now you can go ahead and add multiple pages to a single view. The key is that you must apply the prefix of PM : to the action outcome or return value, followed by the ID of the page to which you wish to navigate. We've got a nice way to navigate between multiple pages in a single view. Now let's add a slick mobile app effect by including transitions. Go ahead and append a $transition equals slide up to the end of the return value on the navigate to second method. Add a $transition equals slide down to the end of the outcome in the second page's p-link component. The question mark followed by the transition will apply an animation to the navigation. Now let's run the code and check it out. When you click the link, it almost feels exactly like a native mobile app now, right? There are a number of different transitions that can be applied. Go ahead and visit the PrimeFaces site for more details. That does it for mobile navigation. While I did not cover everything there is to know, you have enough to get started with it, and I think you'll have a good time. Creating mobile interfaces for applications that we love is a fun task, and PrimeFaces Mobile makes it easy. Next up, we'll take a look at sharing business logic between your desktop and mobile applications. Welcome to video 9.3 of the Mastering PrimeFaces video course. In the past couple of videos, we've been looking at the PrimeFaces mobile API, along with some of its great features. Now, how great would it be if we constructed the entire application for desktop and then simply slapped a mobile front end into it, using the same business logic that we've used for the desktop version? Well, how could we do that, you may ask? We already have navigation and everything working properly in the desktop application. We do not want to write and break anything in order to adapt for mobile. The answer is to use a wrapper for your desktop logic, and we're going to take a look at how to make this work now. What we want to do is provide the ability to write a method or an encapsulation of business logic once and then apply it on two different UIs, those being desktop and mobile. For our purposes, we will apply the Prime Auto Sales Auto Quote Form Submitting Command Button logic to both desktop and mobile. To begin, add a new method to the Prime Auto Quote controller, and we'll name it Save Quote Mobile, returning a string and not accepting any parameters. Now, we will invoke the save quote within this new method, and we can supply a new return string for navigational purposes within the mobile app. So let's go ahead and return PM:2 transition equals flip just for fun. Next, go back to the auto quote view and change the action that is invoked via the command button so that it calls upon save quote mobile. Also, we need to add the third PM page section to the view, providing an ID of successful save, and we'll place some nice informative text within. This is the page that will be navigated to once the submit is successful. Now, if we go ahead and run the application, we can add a quote. Let's be sure to add all of the required field information so that we do not run into any errors. Once we hit the Save button, you'll see that you're navigated to the success page without issue. In this short video, we provided an example of how you can share business logic between your mobile and desktop views. Now, in a real-life scenario, it may be handy to set a success flag if the method that you are working is successful. In the example, we have no way of knowing if the method was successful or not if it failed. Also, we'll want to provide a nice feedback for our customers, so perhaps a new growl message within the new view would be an appropriate medium for acknowledging the success. Whatever the case may be, we can philosophically share business logic between the mobile and desktop applications now, only requiring the coding of a single app. In the next video, we'll take a look at how we can use PrimeFaces push technology and how it can make a big difference for your applications. Welcome to video 9.4 of the Mastering PrimeFaces video course. In this video, I'll provide a brief overview of the PrimeFaces push, the framework that makes it possible to push out messages to multiple clients asynchronously. PrimeFaces push is based upon the Atmosphere framework. Imagine that you're the lead developer for an application that is used to display the latest automobile deals for a specified dealer, such as the Prime Auto Sales application. Now, envision that you want to notify everyone that subscribes to the Prime Auto Sales notification channel that there is a hot new deal in town, perhaps a souped-up sports car or an oversized SUV. Whatever the case, you want to be able to broadcast this message to a number of clients in a single instant. The PrimeFaces push framework makes this possible. In this video, we'll discuss the ins and outs of what makes PrimeFaces push function, and then we'll provide a very brief demo. I don't have enough time to delve into the use cases or fine-grained details of push, but this should give you a good primer on the framework. The PrimeFaces push framework is built on top of the Atmosphere framework, which is basically the most popular asynchronous application development framework for Java EE. The Atmosphere framework is very fine-grained, and there are many different options that it provides. You can build and customize just about any asynchronous messaging system with Atmosphere. PrimeFaces push simplifies the API by adding a couple of annotations that can be used to reduce configuration. If you're familiar with the Java EE WebSockets API, then PrimeFaces push will be a breeze to pick up, as it relies heavily upon the same coding syntax. If you're not familiar, then no problem. It's easy to pick up and very straightforward. At a high level, there are basically three pieces of code, of which a standard push client-server architecture will consist. Those being the client-side web view, which will include an action invoking component, a socket component, and a few lines of JavaScript for updating the client. The server will include two files, one being the code that receives the action and adds the pushed message to the event bus, and the other being the actual push endpoint to which the clients subscribe. I'll go into some details when we build our example in a minute. That said, let's look at what you'll need to do in order to configure your application for use with PrimeFaces push. First, you'll need to add the atmosphere dependencies to your Maven POM file. If you're not yet using Maven for your project, simply download the latest atmosphere jar and add it to your class path. Taking a look at the Prime Auto Sales POM file, we can see that I've added atmosphere as a dependency, and the first time we build the application, the dependency will be downloaded and added to the project. Next, we need to configure a servlet in the web.xml of our project. Opening web.xml, we can see that I've configured a servlet named pushServlet for the class org.primefaces.push.pushServlet. The servlet is mapped to the path of /primepush/*, so that any view URI that contains a path including that mapping will be passed to the push servlet, basically a gateway for the clients. That's it for the configuration. Now let's create a small notification system for the Prime Auto Sales app. To begin, let's construct a user interface that will incorporate a text area and a button. The text area will be used to write a message, and the button will be bound to an action method in the controller class. Open up the admin/messagecenter.xhtml view and add a form after the first form in the view. We will want to add a panel within the view and provide a name of broadcast message. Next, add a p input text area with a value of messagecenter_controller.broadcastMessage. Let's specify a cols attribute, and we'll have a value of 40, and a rows attribute with a value of 30. Next, add a command button to the view and provide an ID attribute of broadcast, a value of send, and an action of messagecenter_controller.broadcastMessageAction. Lastly, add a growl component to the template.xhtml and provide a widget var attribute set to broadcast growl. This will provide the message to the clients. Now, also in the template, we will add a p-socket component specifying an onMessage attribute set to message handler and a channel attribute of /message. Next, add a script element to contain the update logic for the growl component. We want to add the message from our broadcast to the growl component with this JavaScript. Add a function named messageHandler, which will set the faces message from our bean to the broadcast growl component. Next, we'll implement the backend. Open up Message Center Controller class and add a field of type string named broadcast message. Then create a getter and setter for it. Add a field that is final static string named channel and set it equal to /message. Lastly, add a public method named broadcastMessageAction with a void return type. In the method implementation, we will create an event bus object identified as bus. Use the event bus factory to create a default event bus. This event bus implements the publish subscribe and point-to-point messaging. Next, call upon the event bus.publish method, passing a channel and a new faces message object containing the text from the broadcast message field. Lastly, we need to create the push endpoint. This is a class that clients will use to listen for messages. Let's name this class message resource, and we'll place it into the JSF package. Annotate the class with push endpoint, specifying the URI of /message. This class will closely resemble a WebSocket endpoint. Well, because it's basically a WebSocket endpoint. Therefore, let's create a method named onMessage that returns a Faces message, and it accepts a Faces message. In the implementation, simply return a Faces message, the argument. Annotate the method with onMessage, and then add the encoder's attribute of JSONEncoder.class in curly braces so that the Faces message is correctly encoded. That's it. We have the client code, the controller code, and the endpoint. These are the three ingredients for Prime Push. We can now fire up the application and open the Message Center. You should see the broadcast panel, and if you type text into it and hit the command button, the message will be sent and you'll see it displayed on your browser. This message will be distributed to all listening clients. I want to mention that the PrimeFaces documentation contains excellent information on Prime Push. If you plan to use this technique in one of your applications, please read the tutorial. Next, we'll take a look at the other components, those that are available in the PrimeFaces Extensions project. Welcome to video 9.5 of the Mastering PrimeFaces video course. In this video, we'll take a look at a side project known as PrimeFaces Extensions. This project is an open source effort that contains a number of additional components that can be used with PrimeFaces. It is easy to include the PrimeFaces extension library in your application. Doing so enables you the opportunity to take advantage of some custom components that have been built by the community to solve problems that have not yet been addressed by the standard PrimeFaces components. In this video, we do not have enough time to cover all the components, but we will take a close look at how to configure a project to include PrimeFaces extensions, and we will also take a look around the showcase to see some of the components. To include PrimeFaces extensions in your project, you can visit the site, which is linked to the primefaces.org website, and learn how to build the project from source or obtain the project from GitHub. Also, the Snapshot Showcase has a nice showcase of PrimeFaces extensions examples, as you can see here. In this video, we'll simply add the Maven dependency to our Prime Auto Sales project. To do so, first open your NetBeans IDE, then open the POM file of the Prime Auto Sales project. Next, add the dependency as outlined in the PrimeFaces extensions site. Note that you may need to add more than one dependency depending upon the custom components that you'll be adding to your project. In this case, we'll be adding the exporter subtable component to the Prime Auto Sales project, so I've also added the Bouncy Castle dependency to the project. Once all the dependencies have been added to the Maven POM file, you're ready to begin using the PrimeFaces extensions components. If we visit the website and click on the showcase, we can see that it looks a bit different than the PrimeFaces showcase. The components and other features are listed in a menu on the left, and if you click on them, you can see that the documentation for the selected component appears on the right-hand menu. And a Use Cases panel appears in the upper right-hand corner. If we select the individual use cases, then the selected example and source appears in the middle of the screen. In this video, we'll take a look at the exporter component, which allows one to export the contents of a PrimeFaces data table into a PDF, CSV file, Excel spreadsheet, or some other format. If we select the exporter from the left-hand menu, then we can see that several use cases open up. If we click on Multiple Tables, then you can see in the center example that it contains two tables and a couple of links, one for PDF and the other for an Excel spreadsheet. If we click on one of those, it will export the content of both tables into the selected media format. Now, this is done using the PrimeFaces extensions exporter, which we can see in the ActHTML sources below. To add the PrimeFaces extensions to your view, simply add the new namespace with the prefix of PE to gain access to the components. If we scroll to the bottom of the view, you can see the PE:(exporter component references the two tables using a comma-separated list and assigning to the target attribute. This is much the same as the standard PrimeFaces exporter component, but we can do a bit extra here. Another example is a subtable. PrimeFaces offers you the ability to create nice subtables for your view. However, in the past, it has been problematic to export such data into another format. The PrimeFaces extensions exporter can do it easily though, And by scrolling to the bottom of the XHTML code in the example, you can see that the PE exporter tag contains nothing special. Everything is abstracted away, leaving the developer to concentrate on providing easy-to-use solutions for the client. That's it for this video. I know it was brief, but we did cover the configuration of the PrimeFaces extensions. What components you elect to use is up to you. By the way, there's a new book entitled PrimeFaces Extensions in Action, published by Pact, and you're sure to get tons of great information from there on this excellent project. There are a number of great additional components that will add value to your application. That does it for this section. To summarize, we took a look at PrimeFaces Mobile, how to construct mobile views and perform navigation. We also took a look at how to share business logic between mobile and desktop applications. We then looked at PrimeFaces Push and constructed a push notification system for the Prime Auto Sales application. And lastly, we touched upon the PrimeFaces Extensions project and configured it for use within the Prime Auto Sales application. That also ends the Mastering PrimeFaces video course. I hope that you can walk away knowing a bit more about PrimeFaces. Remember, if you ever have any questions, the showcase is your #1 friend, as it shows you the demos and examples alike. I'm Josh Juneau, and I appreciate you taking the time to view this course.